Sound check. Ses deneme 1 2 3. Biraz geç mi geliyor? Hey. Sound check prova 1 2 3.
Okay, we'll wait 2 more minutes and we'll start at 10. For those of you, I'll first one. For those of you, like you have your laptops here and want to build, I'm happy to get you going, and so you can LSD. One, two. Okay, seems that we can start. Hey everyone, my name is Marco. I'm a contributor to the SSV DAO. That's a DVT network-based solution. And today I will give you a basic structure on how to launch your own LSD decentralized staking pool. So if you want to make your own LSD, it's the place. Okay, so let's get going, let's start it. And for those, if you can build it right here. We have like an hour time. So I'll be going through the presentation, and those of you who will, I'll be happy to get you going. So launch your own LSD decentralized staking pool. Now let's go over through the overview. I'll do LSD 101. Basically, how does the pool work? How does DVT work? How to safely delegate running of validators? How SSV's DVT network fits into the picture, and how it helps really developers to build. And then things to work on if you want to build new creative staking apps. I'll give you some tips. Start building. Okay, so let's start with this. Who here is familiar with the basics, how LSDs work, how the pool works, the basic dynamics, so I don't have to... Okay, so this is quite clear, right? Somebody stakes, meaning gives their ETH to the pool, then pool accumulates the ETH, and then it actually needs to send it to some operators who then will run the machines. The hard problem from the perspective of developers is, if you are a developer, basically your main skill set is developing a web app, is developing smart contracts, backend, frontend, and not really running the infrastructure. This is a problem that all LSD pools face, that they need to basically somehow run the infrastructure or have someone run it for them. DVT 101, yesterday there was a lot of DVT talks. Who is familiar with DVT? Okay, kind of all of you, so you know the basic concept. You are basically splitting one validator into multiple parts, and they need to come on consensus what will be the validator signing. Basically, it's like a multisig for validator, a good analogy, but you are familiar with that, so I'll this explanation. Now the hard problem is how to safely delegate running of validators, right? Because if you are delegating running of the validators, you are basically giving someone the keys, and they can potentially slash you. They would probably not slash you, but they can get their keys stolen, and you could get slashed, etc., etc. There are two main approaches, and now there are coming obviously many more. But the approaches are Lido approach and rocket pool approach. Lido has a trust-based approach, meaning they have few operators. Right now is I think something under 40, and they have a trust relationship with them. They trust them. They don't require collateral, but yeah, if you want to duplicate something, what is Lido doing is very intensive. You would have to come to someone and basically persuade them, hey, like I'm building my own LSD. You persuade them that it's worth their effort to basically start operating on your network, which is not easy if you are a new. Then there is the rocket pool approach that requires everyone who wants to participate as an operator collateral, meaning it's very collateral intensive. If you want to run 1,000 validators, you post collateral 1,000 times for each validator. Now, what we have now is the secret LSD sauce, which is a DVT network-based solution. The networking part is very important. Why? Because now what you can basically do is you can make your app just talk to operators in the DVT network, and there are two advantages. Firstly is the networking dynamic. So the coordination is automatic. You dealing nothing. You just look at the Explorer, pick based on your criteria, performance, etc., etc., the reputation. You pick the operators you want your validator to be operated by. But each operator doesn't even have much power, because every validator is distributed, and you are deciding, do I want to distribute every validator between 4 operators, 7, etc., etc. So this is kind of the background. This is what it enables. Now the question is, from the perspective of the builder, of a developer, is okay, I'm sold. But how do I start building? How do I integrate with the DVT network? Basically, it's as simple as this. You just implement the register validator function into your, and in this function you basically pass, okay, I want to register this validator with these 4 operators. So you obviously need to do the key splitting in the backend, but all you do basically is registering the validator on chain. The operators will see it, will pick it up, and off you go to the races. So the takeaway is no need for the app builders to validation. This is completely removed. You can really focus just on building your apps and getting your users. I think that's the next step. Like it shouldn't be hard, and we are working hard to make it a very easy app, right? That is not the main issue, and you can now start focusing on the user acquisition and basically getting the TVL, which is the hard part. So you don't need to worry about the getting into the DVT network that's already there, and you have ability to delegate with zero coordination. That's also an important one, obviously, as I've shown you before. You just call the register validator function, and that's it. That's how you register your validator. But also, it may happen that some responding, so changing the operators is super easy. You don't need to exit your validator. You can basically just function, you can just re-register the validator again with different operators. I mean, there are caveats too often, and you don't want to change too many operators, but to make it simple, you can dynamically change operators requiring any involvement, basically outside of a smart contract call. So those are the takeaways. Okay, so basically this is just a preview of how the repo looks. As I've said in the beginning, if you guys have your laptops and want to clone the repo and build a staking pool that is fully functional, that is actually doing running the validators in the backend, giving token on the front end, you can do so. I, along with some contributors, have made this for the teams to start building, to really see how the whole process works and basically go off to this from there. I have also done a video tutorial for that. And I've tried to make it as simple as possible. Just to give you a preview, if you build it, it will basically look something like this. You will be able to launch a front end to search directly from the repo. There, you see nothing fancy, but you have like all the staking functions, the stake, unstake. You see the pool overview. You can have the map view as well. So basically, it's for you, it's for developers to really like get a hands on a staking pool. On the left, you see my console there, and I'm running the backend. The backend is basically checking the balance, waiting for deposits, pool balance less than 32 there. So, and once I staked 32 ETH here, and it recognizes that the balance is higher. It will create the validators. It will deposit the validator, then it will split the key, and it will register the encrypted key shares with the SSV network. So here are the possible things to work on. If you're interested, and if you run the repo, there are some interesting things that could be much improved, like implementing Oracle. Basically implementing some kind of a trustless or semi-trustless oracle that can also import the chain balances into the execution layer, implementing withdrawal address check. That would be so that the backend would be trustless, meaning it wouldn't be able to trick the smart contract, even if somebody wouldn't be able to basically cause much damage. Adding an execution layer balance, better checking of accounting for MEV rewards and execution rewards, and perhaps MEV smooth there. You could work on nicer front end, and also what could be really cool, an NFT validator contract. Basically, what you could do, you could mint, you could register the validator. You can have the validator be owned by the smart contract, mint NFT, and be fully transferable on chain. So these are some of the cool ideas you could work. Okay, so if somebody is excited to work on this, you can scan this QR code. Basically, you will get to the Telegram group, or you can, and there is a link to the repo, or you can go directly to the repo and clone it. Is there anyone who wants to build? Anyway, okay, great. Yeah, just go forward, get it going, and so I'll be around. I'll be here. I'll be here to help you. Maybe I can go through some of the tutorials here myself. Also, if you want to test it live on Girly, we will be transitioning to Holeski, but it's still on Girly. Join the group. I can give you some Girly ETH to launch validator. So yeah, that's that. Anyway, who is building? Two, right? Okay, so let me know when you are ready to clone the repo. I'll just walk around, and I can open the repo on my end as well. Do I need a QR? You have the address, you have everything. Perfect. If you need it, let me know. Basically, this is how the repo looks, and to just start with the README. And there are basically two ways how you can go about. You can run smart contracts and front end. This will direct you to this tutorial, or you can do smart contracts only. That's without front end, but yeah, I think if you are building, you'll probably building this one.
S A S A. Ha, tamam mı?
One, two, 1, 2. So thanks everyone for coming. For those of you who are still building, I'll try to help you make everything running. And in a while, in a minute, there will be another speaker on the stage. So yeah, we are ending.
Ready? Okay, good morning. Next up, we have Derek, who is going to talk about restaking is for everyone.
Hello, hello. Thank you everybody for coming. Yes, I'm talking about how restaking is for everyone, and that includes solo stakers. So first, I would like to just kind of talk about how what it can do is it can really democratize access and give additional rewards to all of the different people who are involved in staking currently. A few things to note before, I might be talking about Restaking Cloud or K2. Technically, Restaking Cloud is the network, K2 is the protocol, but I might use them interchangeably. A little bit about me, I am working with Restaking Cloud and part of BlockSwap Labs as well. What we're going to cover, we'll get into what we see as Ethereum strengths, define what we mean by safe assets, get into using native delegation, middleware, security reporters, all that. So what are we looking for in restaking? I think that that's really important for us to first address, and that is a way for everybody and anybody to be involved with restaking without altering any sort of operations or adding any additional risks to the Ethereum staking infrastructure. So when we look at ETH, there's hundreds and thousands of dApps trillions of dollars settled every year. It really is this global settlement layer, and there's 870 validators. This is really where people want to be building. That's why restaking is coming into ETH. That is why people want to build on ETH. It is by far the most robust network there is. Now, when we kind of look at Ethereum's core strengths, we see that it really comes down to inclusivity, open access, avoiding centralizing entities, just really anything that can help it grow in any different way. Now, I think it's really important for us to kind of take a step back and define what a safe asset is to get a good understanding of where we're going with restaking. And there's different pillars to a safe asset. The first is that it needs to be low risk. It needs to be something where you're putting your assets somewhere and it's yielding, right? And you don't have to worry about anything external causing risk to these assets, similar to, say, like a government bond. Another thing to actually be a safe asset is the idea that you are yielding in the same currency that you're staking. If it's USD, you're going to want to get USD. If it's ETH, you want to get ETH. Other than that, you are really more or less yield farming for these different types of tokens. Now, once you get this sort of base layer and you get that safe asset, it's easy to underwrite that risk, and you can build additional applications on the top of it. This is really the core pillar of where the monetary system is now. They get safe assets, and they can build additional assets on top of this and keep reusing that capital. So, ETH validator is crypto's safe asset. And when we take a look at this, the solo staker is really the most vulnerable out of all the stakers. They could just be one person. It could be the majority of their assets, the majority of their net worth is in this validator. And when we're talking about restaking, we want to make sure that this person can be included without them feeling like they need to give up certain aspects or certain ideals of being a solo staker. We need to incentivize them just as much as we're incentivizing anybody else within the group. We need that user to continue to hold ownership of their keys, and we do not want their yield to be affected by any sort of third party. So let's protect the solo stakers. Let's make sure that they can get involved and get the same yields as everybody else. So just to kind of sum up where we are so far, we have Ethereum's core strengths. We want to keep these in mind anytime we're talking about anything around Ethereum. We have the largest settlement layer. We have crypto safe asset. And now on the top of that, we want to add restaking, and we need to do this tactfully. There's this concept of ETH at stake. And the whole idea of ETH at stake is that DEXs, money markets, any sort of DeFi app layer can get access to the security of Ethereum without actually slashing any assets on the consensus layer. Right now, nobody can slash consensus layer assets besides the actual consensus layer. Anything that is slashing against them is more of a lien on some sort of withdrawal, or is additional collateral with additional slashing. So currently nobody can slash besides the consensus layer, no matter what app you're running. So now what we want to try to do is offer this concept of ETH at stake while maintaining the idea of the safe asset. We want to make sure that people can get access to these yields, get access to whatever it might be, and we can do this through a concept called state replication. And what state replication does is it creates a real-time replicated version of the consensus layer asset so that it can be tracked on the execution layer. So now we have this concept of native delegation, and we have a native delegation bill of rights. We want to make sure that anybody and everybody who accesses restaking is able to do so in a way that's safe for them. They're not putting assets at risk, and they are able to have the freedom to choose anything they want to do. We want them to maintain full optionality, run any software they want, run clients, use DVT, use solo staking. It really should not matter when we're talking about restaking. Everything should be the exact same as it was before. So now we have what you put ETH at stake with the same concept of native delegation, and what we get is this ability for people to access different validators and different ETH at stake for their individual network. Again, without being able to slash the underlying validator, because that's how Ethereum works. We want restaking to really map exactly how Ethereum works itself. Some key features that I want to run through as far as what is possible with native delegation. There's no need for withdrawal credentials. That means that people hold on to their assets. To actually get involved with native delegation, it's quite simple. Sign a transaction with the signing key. There's a few different ways to do this. There's through a web browser, which a lot of people aren't comfortable with, but that's okay. There's also a CLI where people can run and then basically just upload the proof. And once they're done with that, they can set their fee recipient address and they can start receiving ETH payouts for the restaking. Now, what's important to keep in mind here is that these validators are only able to maintain being part of that restaking network as long as they're maintaining a good quality validator in Ethereum. If they're not upholding everything that's good in Ethereum, they can no longer natively delegate. We really want to tie that connection together with these consensus layer assets. Now, with native delegation, to keep that idea of safe assets, there is no additional slashing risk to an ETH validator. Really, I'll get into this a bit later, but any sort of slashing or any sorts of payouts are handled at the pool level because you have middleware on one side, you have ETH stakers on the other side, and this can be handled in the pool and not put that risk on these restakers who aren't exactly sure what software they're running or anything like that. So at the end of the day, people can keep the exact same business logic. If they are running for LSTs, they can continue running for LSTs. All validators are accepted, and this is really incentivizing this base layer. This is saying that node operators, whoever's holding the signing key, whoever's running the validator, that is who gets access to this. And again, this is all entirely on smart contracts, so there's no opportunity for a veto or anything like that, and it's completely deterministic and, again, passive for these stakers. So now, to get an idea of what's possible with restaking, we want to take a look at what would the progression be of assets that people can build. So from the onset, we have infrastructure, and I really think that a good analogy to this is the idea of the GPS, where the GPS originally for military use, $300,000 product. I don't know, I'm making that number up. I'm sure it was super expensive when it first came. And it was just reused for military operations. That's really the infrastructure of where we're at when we're talking about restaking, right? Node operator networks, Oracle networks, really anything that is very fundamental. But as this moved up, they put that military device, they put it in a car, and people can finally find out where they're going, right? And this is very similar to the idea of a DApp layer, where people have different sorts of applications that they see a need for, and they can bring in restaking to solve those issues. Now, where I think this gets super, super exciting is once we get into native utility. Because native utility is now where the GPS is on the smartphone, every app is tracking your location, they're giving you relevant ads, they're doing whatever it is, you don't even think about it. And that's where restaking is going to get to. It's more closely related to, pinging an API point to access restaking, not where you need to go through this long process of getting additional software set up. It's just right there, available, simple to use. The middleware have a very easy time getting through this process, right? Because they can define any sort of slashing logic they want. And when I say slashing logic, if we go back here, slashing with infrastructure, that makes sense, but slashing is actually a good thing, where if somebody wants to use restaking and the backing of Ethereum for account recovery, and every time that they want to recover an account, there's a little bit of a slashing, that's actually a very positive thing. That means that it's working, means that account is recovered. So once a middleware defines what that is through a simple TypeScript type logic, they go into the DApp and they can choose which ETH or how much ETH that they want to borrow. And they can simply go in there, they say, I want to put up this much ETH, this much, because this is how much I want access to, and they will really just pay for services as they go. And because this is all smart contracts, this is all very symbiosis, people are able to modify the logic they want anytime. They can cancel anytime, they can come back and change things, they can add additional security, whatever it is that they want to do, but it scales with them very simply, and they don't need to talk to anybody, they just go to this app, and they're there. So really there's two ways that middleware are able to pay for their service. There's one, they pay for interest to the restakers for how much ETH that they want, how much of the ETH at stake that they want. But then there's also the slashing and liveness, and this is more of the pay-as-they-go type of service, where every time a call happens, they pay, I'll get into the reporters a bit later, but they pay for these reporters to verify different logic or have these different types of slashing. Now, the middleware could decide to pass these slashing risks onto a separate node operator set and not pay for them themselves, or they could have different people pay them every time that the service is run, but at the end of the day, they're the ones that are taking out that initial loan for this ETH. It's where we come up with pay as you go, pay as you grow. You can start off with $100, you can test this all out, you can cancel anytime, get that ETH back, but as you want to add additional services, you come up with different ideas, you want to try something else out, you are able to simply do that. You just go back to the app, you set what your new logic is, you decide how much ETH that's worth for you to have that covered, and there you go. Now we're getting into the reporters. These are the vigilantes. It is a completely ad hoc network. These are the slashing mechanisms where people can come in, anybody can be a reporter, download the simple software, and any sort of that logic that the middleware has outlined, these are the ones that are enforcing it. They're super lightweight, zero-knowledge proofs. So again, you have your old smartphone. Nobody wants to use their old smartphone, but if you can use your old smartphone to make a little bit of money, buy yourself a new smartphone, that's where the reporter comes in, because it's so lightweight, it's completely automated, anybody can run it, which really gives so much additional decentralized support to this restaking network. It's not one person who's enforcing slashing, it's anybody who wants to enforce the slashing can enforce this slashing. So here's a bit of a diagram on what this could look like when we're talking about an ad hoc ZK network. You know, we have reporter number one here. They're always online. They're made a business out of it. They want to make sure that they're going to catch every slashing report that they can. They want to report. Reporter two, currently offline, no big deal. Reporter three, sometimes they open up the laptop, let it run. Sometimes they don't. They don't really care. Same with reporter four. Here's really an overview of what the reporter does. It's ad hoc network. Anybody can join or leave anytime. There's no penalties. They're not putting up any additional capital at risk. So what they're able to do is they can just, when they're online, they can get paid. When they're offline, they don't get paid. And all of this payment that they're getting is in ETH. There could be some separate agreements where people are getting paid ERC20s, but the whole crux of restaking, well, staking and now restaking is ETH. And these reporters, even though it's ZK Tech, it's super fast. We actually have an implementation of this already in another one of our protocols, the reporter. Now we made it more generalized for Restaking Cloud, but it's already live in mainnet if people want to check it out. It does, you know, it's milliseconds of time it takes for these reports to go through and be verified. Now, there's this concept of preferred reporters as well, where people can build out specialized services, specialized reporter services, but there's going to be a lot of basic stuff for people to run as well. So now, where do we go from here? Got a lot going on. Let's figure it out. The preferred delegations and preferred reporters. So from the onset, everything is generalized. Anybody can be a middleware, anybody can be a restaker. Everything, it's perfectly matchmaking type of system. But as things progress, people, as they get more and more sensitive information or more and more sensitive like protocol operations that they want on restaking, we can add in these preferred delegations. And what that could look like is a protocol could say, hey, I need 100 ETH at stake of security, and I trust these particular node operators. Maybe they want to go with solo stakers, maybe they prefer to go with commercial node operator or their friend, doesn't matter. And they could have a separate agreement saying, if you're going to provide my ETH at stake, I'm going to provide you some additional incentive. Now, even though the pool is completely auto-managed, what this will do is completely section off a piece of that ETH at stake for them. So if liquidations do occur, or if restakers decide that, hey, I want to leave because there's nothing holding any restaker there, they're able to know that they're at least covered with these particular people. Now, on the other hand, preferred reporters are also very interesting because there could be specialized services that are run off of these. You know, as the more and more I talk to people, the more ideas they give me on how this stuff can be ran. And this preferred reporter was actually from somebody else outside of our organization who came up with some of these ideas, saying that they could run services that if there are liquidations, they can essentially cover that and make sure that they're the ones who are winning these ETH bids and making sure that these people are made whole afterwards. Is this another app chain? Not currently, but it will be, and I'll tell you why. Because when we're talking about slashing and when we're talking about, you know, this base level where we're talking about right now, we're on the infrastructure layer where there could be slashing and liveness, and these are less frequent types of events. It doesn't matter as much, but the costs of ETH are going to get more and more expensive. So as this develops, what we're going to do with Restaking Cloud, is deploy a separate app chain for it. And what this allows for is these super fast interactions where people can access these reporters, access ETH at stake, similar to an API point, without actually needing to spend all of that ETH gas cost. A lot of yield going on here. So when we get to the yield, where are we at currently? We have staking yield, we have MEV, we have LST-Fi, all this amazing stuff. Now, how do we add on this ecosystem yield on top? And that's where people who are coming in as restakers, they're staking a token, they automatically get this LP token. And this LP token is yielding in ETH from all of the different applications that are building on top of Restaking Cloud. Now, this is powerful because they don't have to worry about anything besides that their ETH value of this token is accruing and accruing. Now, this token, because it's a simple ERC20 LP token, can be reused in DeFi. It can be used in literally any different ways that people want to do, and it'll just accrue, accrue, and accrue. We're looking at about a 5 to 10% APR is estimated for the restakers from the onset, all in ETH. So we want to grow the Ethereum ecosystem. And to do that, again, we want to keep solo stakers safe. We want to make sure it's fully inclusive. Anybody who wants to join can join on any level. We want it to be completely available, and we want full participation from anybody who wants to. That's why we made the reporters so simple to run, is because those reporters can be anybody, old laptop, old computer, run it. Restakers, anybody using native delegation, 860,000 validators are available to natively delegate, plus the LST tokens. And we want to make sure that those people, the base network, is not at risk. So how can you get involved? There are really 3 different ways to get involved. There's the low lift. You can restake your LSTs, you can do your native delegation, and that keeps things very simple for people. They just come in, they just collect more and more ETH. Now, what somebody else could do is they could say, hey, well, I also want to run the reporting software. They can download that software, it auto updates, it's very simple, lightweight, very easy to do. Now, the heavier lift, obviously, you want to develop an application specifically for restaking or increase the security of your app. That is all possible as well. Now, somebody could also come in here and say a middleware or somebody building an app chain could have a bunch of ETH at stake as well. They could also become a reporter. So what they could do is they could ensure the security of their network. They could hedge off some of their costs with being restakers themselves and have their app be run. So this is something super powerful for people who are already working with staked ETH, who already have signing keys, who already have LSTs, whatever it might be. They already have the node infrastructure. People can kind of pick and choose, right? So it could be very easy for a solo staker to use native delegation, just basically sign up with their signing key, and then set their fee recipient. They're done. Then they could run an additional software. They could run this middleware on the same machine, get paid for that as well, and they can just sit back, collect ETH. And that's what we have. So thank you, everybody. Are there any questions?
So you made this quite bold statement that you can just earn another 5 to 10 or 5%, 10% with these restake initiatives. Where do they come from? It's usually always a risk-return question. So additional yield or interest doesn't come for free. Right. So that's where the middleware is actually paying for access to this ETH at stake. If you look at it, where the middleware are the ones who understand what the risks are to their application. The middleware are the ones who wrote the contracts. They know what they want done. So it's more like they're paying for a service, and what they're doing is they're paying to get access to this ETH at stake. And they're also paying every time that they have a different type of slashing event, whatever it might be. And because the middleware are taking on this risk themselves, it's not a separate party, they're actually able to do this with essentially a bit of leverage. So they can pay more for less. Slashing events might hurt their position a little bit more, but they understand the risks that they're taking. So the actual ETH restakers in this circumstance can get more yield for their ETH.
Other questions? Okay, then let's thank them.
Thank you.
Next talk is in 10 minutes. everybody. Next up, we have Dimitri from Lido and solo stakers. Wake up.
Hello, hello. Oh, I've never used this mic before. Let's give it a try. So, today we're going to be talking about one of the most unexpected topics on ETH Staker event. We're going to be talking about solo staking. And you probably think that I'm joking, but I'm not, because we're going to be talking about solo staking with Lido. The thing that you've never heard before, and you will hear now, and you will learn now. Let me introduce myself. Hello everyone again, my name is Dimitri. I'm a technical leader of a group of contributors in Lido working on community staking. But why the topic of solo staking and community staking is even interesting for Lido? I mean, everything's going well. These huge node operators have a lot of stake, everything's going fine, let's bring more stake to them. No, for sure not. Lido DAO mission is to make staking simple, secure, and decentralized. And solo staking, by far, is one of the best ways to improve the security and decentralization. That's why we are talking about it today. Let's do a quick recap of the things that you do need to be a solo staker at the moment. First of all, you need huge bunch of capital. To be precise, at least 32 ETH. Then you need hardware. Then you need to cover operational costs. Pretty significant DevOps skills to maintain all this software and complexity. And the last but not the least, you need luck. You need to be lucky enough to get this huge, juicy MEV, because otherwise you will sad and your incomes wouldn't be that great. And it all looks pretty huge and complicated. Solo staking simple. Again, it is really complicated to be a solo staker at the moment, but it is by far the best way to improve Ethereum decentralization. That's why the main goal of Lido Community Staking Initiative is to make staking simple and more accessible for anyone. But how we can make it simple? What we need to do for it? And at this point, you are probably thinking, okay, I'm hearing a talk from Lido about some product. And these huge protocols, they just make unilateral decisions. They don't care about opinions of community. They just throw a product on a market and you either take it or you go away. Let's find out why it is not so. To be precise, any decision, any significant change in Lido and Ethereum protocol is made through the following process. So the first comes the proposal, prepared either by Lido contributors or basically anyone in the community. Then the proposal is revealed to public, and there is a public discussion. Anyone, both LDO holders and just participants of community, can share its opinion, and then we move back to proposal to refine and improve it. And the process goes on until there is an alignment between community, LDO holders, and the authors of the proposal. And after that, we can move to implementation. So now, guys, it is time to reveal the proposal. We are at the first stage, and then we expect public discussion. Introducing Community Staking Module, also known as CSM, a staking router module made for community stakers, by community stakers, and staking fans, with the key feature for sure being permissionless entry. But you might ask, are you guys staking community? What do you mean by that? Actually, term community stakers was introduced not only by Lido, but many participants of Ethereum ecosystem. And it is a bit broader term than just solo stakers, because it includes not only individuals, but groups of people running Ethereum validators, being aligned with Ethereum goals, and what is, I think, the most important, with the main motivation being not financial. Because if your motivation is, first of all, financial, you will end up as a professional node operator, and that's great, but that's the other case. And when we talk about community stakers, we see these groups or individuals being aligned with Ethereum and being motivated, first of all, not financially. To achieve outlined goals to make solo staking simple and accessible, it is proposed to focus on these three key values of community staking module, with the first one being reduce barriers to entry. At the moment, again, it is extremely hard to be solo staker with all this capital and other stuff. The second key value is to improve Ethereum resilience. The more independent actors are in Ethereum network, I would like to put a special emphasis here, not in Lido, but in Ethereum network in general, the more secure and decentralized Ethereum network is. And for sure, we want to make solo staking more profitable. Even though we see community stakers being not financially motivated, at the end of the day, we all need to pay bills. So if we can make it more profitable, then let's make it more profitable. And let's dive deeper into the list of key design and cool features to get you a bit more understanding of what we are proposing today. Let's start with design, and here I want to focus on 5 main aspects. The first one being nonlinear bond, integrations, permissionless entry, first in, first out stake allocation queue, and performance oracle. For sure, we start with permissionless entry. And there's nothing to add here. It will be permissionless. Anyone would be able to use CSM. Let's move on. Integrations. This is a key part because when you develop a protocol or a part of a staking protocol, it is mostly on-chain things and off-chain tooling. But what you need to do also is client side, is hardware and software used by validators itself. And despite trying to invent yet another bicycle or create yet another software for validator preparation, we propose to do integrations with well-known solutions, both hardware and software, so that it will be as easy as set it all in 3 clicks using your preferred existing solution, and then just join Lido. The next cool feature or great design feature that I want to talk about is nonlinear bond. According to research of Lido contributors, at the moment, currently, right now, bond values from 4 ETH to 2 ETH seems to be sufficient to cover different grades of risks. But what we believe in, by we, for sure, I mean Lido contributors and specifically my team, that the more validators are ran by a single node operator, the less can be the bond requirement, because the bond is associated not with a single validator, but with the node operator in general. So at the end of the day, we have more coverage for individual extraordinary cases while still allowing lower entry barriers. Since for validator creation, node operator need to lock bond, it means that it will be fair, the most fair option, to allocate stake to the node operators in the same or in similar order they locked bond. That's why we propose to use first in, first out stake allocation queue for node operators. The faster you come and upload bond, the faster you get your stake, the faster you can start your operation. And the last but not the least design feature is performance oracle. Keep in mind that while designing CSM, we're not designing a new product from the ground up. We are trying to implement staking module that need to work together with Lido protocol. And the default system currently used in Lido protocol to distribute rewards is just a proportional system. It works fine for permissioned operators because Lido contributors have other ways to interact with them to say, hey guys, there's something wrong on your side, please fix the performance. And they will do, because professional operators, they put reputation as a stake. With permissionless staking, it is not so. We know nothing about operators. We know something about them, but not about all. That's why performance oracle here is crucial to create dependency between performance and rewards. At the same time, we think that it wouldn't be correct to ask home stakers and solo stakers to aim to this 99999 numbers, because it is hard and pretty much useless for Ethereum network and for them. That's why we introduce performance threshold, a value that should be determined by Lido DAO. And if node operators, validators perform above this threshold during period, they get socialized rewards, like everything fine, no matter if it is, for example, 97 or 96% efficiency, you will still get the same rewards. While low performance who are below this threshold wouldn't get rewards at all. Why it is needed? Because we don't want to incentivize people who just create validators and do nothing or don't care about performance at all. But we want to ensure that small power outages or internet outages or other things, they would not influence the rewards for solo stakers. So yes, the rewards above performance threshold will be socialized, and below performance threshold, no rewards, sorry. Now let's briefly talk about cool features to give you a better understanding of why you as a solo staker would probably prefer to use community staking module. Let's start with low bond. We know that bond is a crucial feature for security. At the same time, we know that Ethereum ecosystem evolves and Lido protocol evolves, and there are recent advances in different types of reporting and security assessment. And we want to offer bond as low as possible while still maintaining decent protocol security and security for STETH holders. At the moment, it looks like 4 ETH bond is a good option, but given that it will take us about 6 to 9 months to move to mainnet release, I think that this number will be even lower. Simple UX is very important. You like using your iPhone or your Android because you can access needed features within several clicks. You just do it, you just take your phone, and it is easy and understandable for you. So why not to make solo staking experience the same? You just prepare your validation setup using UX pretty similar to your iPhone or to your Android, why not? Then you do just one action in CSM UI to upload your validator keys and provide bond, basically sign in only one transaction. And that's it. The only thing you need now is to operate and claim rewards whenever you like, in any amount. Like you can claim it each month, each half a year, each year, and in any case, it will be one transaction for the whole node operator, no matter how many validators are, no matter how many rewards acquired. So this 3 steps is by far the simplest possible UX for solo validation. Gas fees has been a problem on Ethereum for a long time. And it will be so because it's a base layer, it's a base security layer, so gas fees cannot be low. But what can be low is gas costs. We can reduce the amount of gas needed for operations. And in a typical flow for solo staking with liquid staking protocol, you need to do all this huge stuff, so many operations, so many gas spent. With CSM, we propose to minimize it to only 2 operations. Create your node operator and upload validator keys and claim your rewards. Again, anytime, in any amount, for any amount of validators. And the rest will be your savings. Let's talk about MEV. You all know MEV, guys. You all know it's a huge lottery. And that's the typical graph. I would say it's optimistic graph of MEV rewards per one validator. Most of the time, MEV wouldn't be that large. But from time to time, it can be enormously huge. And given that a single validator within the current state of Ethereum will most likely produce from 1 to 3 blocks a year, it's always a matter of chance if this 3 or 2 blocks within the whole year will be lucky, and you will be lucky enough to get this huge MEV. And the worst case here is if you are not. If you are running validator for a year, for 2 years, and you were never lucky to get this huge MEV spike. With CSM, the situation again will be totally different. There would be no spikes and no pitfalls. Why? Because by design of Lido protocol itself, MEV is smoothened across all Lido validators. And given the size of the number of Lido validators, you can be confident that in most cases, you will benefit from these huge MEV spikes. Because no matter if it is your validator or any other Lido validator, this MEV will be evenly smoothened between Lido validators and STETH holders. And the last thing I want to share about cool features of CSM is that there wouldn't be any tokens involved except for ETH. No LDO, no special LP tokens or any other tokens. When you validate Ethereum, you need to provide Ethereum as the collateral, ETH as the collateral. And if you use LST protocol as a supplementary tool, we see no reasons to ask for something else except for the base collateral. And what is more important, that your rewards will also have form, not of ETH directly, but most likely of STETH, which is 1-to-1 ratio with ETH. And just keep in mind that Lido is the only protocol to offer permissionless withdrawals in any amount. So you can even claim your rewards as a withdrawal NFT if you want, if you don't want to deal with STETH. But another cool feature of rewards being acquired as STETH is that you can not claim your rewards for a year, and don't be afraid that your rewards are just sitting here and doing nothing. Since it will be STETH, your rewards will acquire additional rewards. So we used to call it compounding. And that was basically it about design. Now let's take a look at the timeline, what we expect in case of, for sure, DAO and community approval. At the moment, we are at development, architecture, and prototyping stage. In case of DAO and community approval, we can move on to audits at the first part of 2024. In Q2, Q3, we aim to launch testnet, and you guys are all invited because, again, it's permissionless. And by the end of 2024, we are aiming to propose the module to be launched on a mainnet. To keep track of all the things happening, to get recent updates, and to make sure you will be the one to participate in testnet, get help and support, please join Lido CS community today. Make sure that you also already visited, or if not, make sure to visit Lido booth. Do 3 simple tasks, and at the very end of the day, today, there's going to be a raffle. And you will get your chance to win one of these magnificent boxes. So don't miss it. And I want to end up the talk with a simple thing. Today, I shared the proposal with you. And the next step is public discussion. So I kindly ask all of you guys to share your opinions on what do you think about the proposed CSM design. You can do it either here after the talk, near the booth, or, which is way better, is to scan this QR code, to go to Research Forum Proposal, and under the proposal, leave your opinion, no matter what it is. You can say, this proposal, I don't like it. I mean, it can be done better. Feel free to do so. Or you can say, I support the proposal, or any other option. And if you guys are working on development of tools for validator preparation, or for any other tools that can be beneficial for solo stakers, make sure to outline it in the comments to the proposal, so that in the upcoming snapshot voting, your company and your group, your team, might be outlined as potential partners that LEGO committee should consider. And that's basically it. Thank you so much.
Questions?
Hey, great talk, Dimitri. Can you maybe just zoom out and clarify how is this different than what Will was talking about with the DVT stuff? Is that a separate module? Are we talking about separate modules within Lido now?
Yes, exactly. So it is important to speak about, to define 2 terms. Community staking initiative in general includes permissionless staking, DVT, and any other options for community stakers to participate. Community staking module in particular, this is the permissionless module, yet another module for Lido, for staking router, that will be mostly focused on solo participation with bond. And there are 2 reasons to think about this module. With the first one being to offer more for participants, because some participants might say, okay, DVT is great, but I would on my own. And they should have option to enter Lido. And the second option is that at the moment, currently, we think that this module is the simplest one across the whole community staking initiative, except for simple DVT that will, I think that it will go live on mainnet way earlier. That this module can be implemented with DVT modules. And even when full-featured DVT modules are implemented, it will be just a variety of options for community stakers for them to choose. Either they want to use DVT, if they want, which technology they want to use, and if they want to be solo, to stay solo, they should have this option. So that's the main goal of this module.
So no LDO bond, but how about LDO incentive?
Oh, that's that's a great question. So yes, definitely no any incentives regarding the community staking module, again, will be discussed publicly. Nothing is proposed yet. Feel free to make your proposal. I mean, it's an open world. Lido is a DAO. Anyone can propose. But at the moment, developers team, contributors team are not considering any specific incentives in LDO. Because again, I don't think, for me personally, I don't think that paying with additional tokens or incentivizing with additional tokens is a good option. On Ethereum validation happens on Ethereum. Rewards are in Ethereum. So the best way to incentivize solo stakers from my perspective is to offer better staking fees and lower bond so that it will be way more capital efficient than typical solutions.
This might be an obvious question, but when the node operator brings a bond, they'll get STETH for that bond, right?
It depends actual implementation. We are currently discussing several options. What I can confidently say is that bond will definitely be staked, but I cannot say for sure in which form it will be. The simplest option, yes, is to convert it into STETH and store it on the CSM contract. While there still might be other options like re-architecture of the core protocol to introduce bond feature on a protocol level, in this case bond will still be staked but wouldn't be represented as regular STE, so it will be more complicated mathematics around it. Stay tuned for updates and share your opinion, what you think the best. Again, in the proposal, this topic is briefly discussed.
And can you maybe just like what you think the biggest like why should a solo community node operator go with this as opposed to, is it mainly the lower bond? Is it the ABV smoothing? Is it all of the above?
I would say all the above. And as a node operator should obviously not choose Rocket Pool. I would say that node operator should consider possible options and make an informed decision on which options which is more comfortable for him. From our side, we want to focus on simple UX, low entry barriers, and relatively profitable economics of a module. So that's the main features.
Thank you. If there are more questions, you can ask Dimitri in the hallways while we get ready for the next speaker again. Okay, next up we have Mike and Nick, who are going to present us a utopian future.
There we go. Well, thanks everyone for coming. Before we start, just want to give a quick shout out to ETHStaker for putting on an incredible event. It's events like this that makes Ethereum so special. I'm Nick. This is my partner Mike. We're the founders of helping to build a decentralized infrastructure for a utopian future.
All right, so I promise this is going to be a positive presentation, but first we have to get a hard truth out there. For one, the Ethereum vision is fully inclusive. Anyone in the world should be able to use the network to transfer value in the same way that the internet has been used to transfer information for 50 years now. However, the current design of Ethereum's infrastructure layer, but things like L2 sequencing, building, searching, the list goes on, unfortunately, it has become very exclusionary in practice. So today, we're going to discuss the work being done to change that second statement to be just a little bit more utopian.
We live in a semi-centralized world that is more fragile than we like to admit. If an operator with thousands of validators is slashed, the Web3 world collectively panics. That's not acceptable. Ethereum can't take on the world's financial needs if value can be erased so quickly. So how do we end up here? Simply put, the ecosystem is highly competitive and requires considerable technical skill, high levels of capitalization, and business development efforts to succeed. Such significant barriers to entry make it difficult for decentralized actors to thrive. I'd like to note that this is not unique to Ethereum or proof of stake. Bitcoin miners face the same pressures as well. In the world we live in today, these barriers to entry are the cause for centralization. As an example, because permissionlessness is susceptible to Sybil attacks, most permissionless projects rely on cryptoeconomic security, also known as bonding, to align incentives. This means that you need considerable assets to participate. Not very inclusive, is it? Obviously, Ethereum is not a dystopia, but it is imperfect. Ethereum needs diversity to reinforce its credible neutrality, which means we need more variety in governance mechanisms, client software implementations, operator geographic distribution, and operator types to fulfill Ethereum's vision.
So for just a moment, let's just imagine that these barriers don't exist. Let's imagine a beautiful future, a utopia, if you will. What would that look like? So for one, providing infrastructure is still critical, so it would still be rewarded really well. But what if, instead of paying specialized, centralized entities, we could include absolutely everyone? To borrow one of Vitalik's dreams, the average person should be able to run a validator on their phone, perhaps without even realizing it. In this world, the barriers that currently exist today are gone. Anyone can help out, no matter how little time or knowledge you have. And in this world, stakers don't need to be professional engineers with high availability setups, complex, expensive hardware, because in this world, decentralized individuals outcompete centralized entities. In short, the utopian vision is one where Web3 infrastructure is instead subjected to decentralizing forces.
So let's talk about what's being done to get us to utopia, and one problem that still remains unsolved. First, trust requirements are the most obvious problem with Web3 infrastructure, and so they get a lot of attention. Ethereum's core devs are implementing several key upgrades like EIPs 7002 and 4788, and app layer innovations like DVT and ZK Oracle systems are attacking this problem higher up the stack. When it comes to education, community organizations like Ethereum Foundation and ETHStaker are doing a fantastic job providing documentation and guidance to new users. On the hardware front, there are plenty of things to look forward to here, like state expiry and data availability sampling. However, this still leaves us with the problem of fragmentation, which remains as the biggest unsolved problem in Web3 infra. As of now, there simply isn't a simple way for projects to hook into a large decentralized group of operators without building their own community from scratch. This is particularly problematic for projects that can't afford to incentivize operators heavily, yet still have the same critical needs. From the other side, operators have to actively seek out projects to provide their services. And participation is complex and costly because the operator tooling for every project is unique. To fix this, we need a way for the average person to automatically hook into new opportunities. What we need is a holistic technology platform to connect operators with projects. In conclusion, someone needs to build real-world relationships between protocols and operators. And, even more importantly, we need an extensible, open standard for anyone to benefit from this effort. Of course, it's critical that this remains free and open so that we don't create a single sort of centralized entity that's controlling things in between.
Of course, this is exactly what NodeSet is building. We made the problem statement, now we're going to solve it. So, an open platform to connect node operators with projects. That's what NodeSet ultimately represents. If you're a node operator, you can work with NodeSet to discover new opportunities to earn. And if you're a project looking for decentralized infrastructure, NodeSet can help you connect to a large network of very capable, totally decentralized operators.
So there are a couple things we want to do to empower the individual operator. So considering all the centralized forces we previously mentioned, we think it's critical to build a platform that caters specifically to the needs of independent operators, connecting them to protocols and services in need of their skills and compute. I want to reiterate, we're focused on independent operators and small and medium business entities, not globally scaled professional staking providers. We see a number of opportunities to empower these smaller entities. First, independent operators generally don't have industry reach or the ability to source capital at scale. We aim to build relationships with protocols, businesses, and service providers on behalf of our operator base. Our desire is to unlock access to for those who don't have the resources to compete. Second, independent operators cannot build differentiated products with partners via custom smart contracts or technical integrations. Nor do they have the resources or professionalized audits. NodeSet is building a robust engineering organization to serve this need. Finally, independent operators lack the necessary tooling and automation infrastructure to easily access new opportunities. This limits the potential world of operator participation and artificially restricts operator supply. While many ad hoc efforts are underway across the ecosystem to improve the situation more generally, we hope to accelerate this and build our own infrastructure if necessary.
So this is the simplified architecture that we have for the operator experience on NodeSet. We're still in the early stages of building out our vision, but we ultimately want to create a platform where anyone can connect to new opportunities to grow their operation further. You can see all those different opportunities down here, but realistically, the list is endless. We could keep going. You'll see a little bit more, a little further down, but the idea is that after installing Hyperdrive, our node operator client, this client software will automatically connect you to packages that hook you into new opportunities, either with or without your consent, depending on how you want to set it up. Obviously, you're going to have to make sure you trust the repositories that you hook into if you want to do it automatically. But the vision is that straightforward. You install a single piece of free and open source software, and suddenly you're earning more with the exact same setup. As an example, let's say I'm a small home staker with just a few validators, and I'm making a little bit of ETH, all well and good. But I bought a big disk drive for this. Currently, you need that. Once state expiry is implemented, I now have far more storage capability than I actually need in order to do my validation duties. So simply by downloading Hyperdrive, now I can hook into a way to fill up my drive with data from protocols like IPFS. We were speaking to Portal earlier. There's a lot of data availability solutions out there that need storage and are willing to pay for it. So over time, my home operation is now providing numerous services and earning multiple revenue streams from the same device. Nothing has changed except for I've installed Hyperdrive. New opportunity, no downside. The only step that I had to take was installing this thing, going through the very minimal installation process. So for some opportunities, it won't be that automatic, obviously. If you want to participate in something that requires user input, you will have to explicitly install that package and run through the installation. But it's as simple as a single command. The idea is it should be just like a package manager. We expect that anything that has manual setup steps are probably going to provide higher benefits. And some of the projects that we're working on are good examples of that. We'll get to that in a little bit. But the idea is that you can discover these packages on the official NodeSet package repository website, or you could just, if you don't trust us for whatever reason, you could go to some fork or make your own, or again, the possibilities are supposed to be endless here.
So on the organizational side, organizations face their own hurdles when it comes to putting together a decentralized strategy for their products. First, there is the challenge of access. There simply isn't a way to plug in to large groups of decentralized node operators. As things currently stand, each and every organization has to essentially scream into the void and hope that someone hears them. If they're lucky enough to get operator interest, they have to think about community building and ongoing management of that community. If you don't have the luxury of time to build such a robust community, protocols are stuck in the unenviable position of enticing operators with large incentive programs and substantial budgets. And of course, there's absolutely no guarantee of success. We expect platform lock to be a growing issue that many new protocols start to face when they come to market. And our goal is to really eliminate this pain and make it straightforward to technically integrate the NodeSet platform and its growing population of operators with your protocol or service.
We should maybe mention that we have currently about 100 node operators, and we haven't really advertised it all, mostly because it's easy to say, hey, join, we'll give you free ETH.
That's right. And
it's not a scam, I promise. You don't have to send us one ETH. We're not going to send you 2 back or whatever. We don't know Vitalik, although we'd like to.
That's right.
But this will grow. Thousands of node operators.
Yeah, we're lucky enough to be sort of plugged into the Rocketbowl community, and we think that many of the node operators there will be more than happy to participate in a system like this. And frankly, when it comes down to it, the bottom line is that we want to enable protocols to focus on doing what they do best, and really that's building products that delight their users, and not focus on recruitment.
Yeah. So right now, NodeSet itself is the only entity building for our platform. But this is the other side of the equation from the architecture that I was talking about before. It's the same architecture, just sort of the flipped version of it. We expect the value of this approach to be pretty obvious to every project. If you need a set of operators for your network or your protocol, it should be easy to just define the requirements and then immediately establish those relationships. Just build a NodeSet package or reach out to us. We'll help you build it. As an example, let's say I'm a game. I'm building a game that needs some distributed infrastructure, or I'd like it to be distributed, ideally, so that it doesn't go down and all my players hate me. I have some incentives to attract operators, but my requirements are easy. Although they're easy, they're relatively specific. They need to store a few kilobytes of data. Okay, that's not so bad. But they also need to respond to requests within 100 milliseconds. Otherwise, the state is stale, and that's no longer useful. The game has moved on at that point. So today, I would have to use a centralized provider. I have no other option, because sourcing multiple operators with the ability to provide that kind of service and writing tooling for all of them and supporting that, it's totally infeasible. So I just have to accept as a game, okay, maybe if I'm Activision Blizzard, then I can, figure it out. But realistically, every game is going to be using AWS or some kind of centralized architecture, and they just have to accept downtime as part of the equation. But with NodeSet, everything changes. I can create a simple NodeSet package, in this case just a few lines of code to define my requirements, and the incentives provided. If you don't send your request back within 100 milliseconds, you don't get paid. Simple as that. And you get paid just a little bit every time you do. It's very simple, straightforward. I'll write this thing up, I'll publish that package to a repository, and any operators who meet my requirements will automatically come online and start providing services.
So moving on to some things we're currently working on. As of now, we have 2 major projects in development, and we're very excited for both of them. Primarily, our focus right now is on the staking realm, but as we've discussed, and as we're showing here, the possibilities are endless. So first, coming up hopefully in December, we'll be providing integrations for Stakewise V3 vault administrators who are interested in decentralizing the operation of their vaults. The first example of this is a partnership with Gravita, which we expect to be live by the end of this year. So if you haven't heard of them, Gravita is a DeFi protocol that allows you to borrow a stablecoin against your LSTs. And with the Stakewise V3 vault we're building for them, we're really excited that we can provide them a new and unique way to integrate a new type of collateral onto their platform, which benefits from the security and the redundancy of nodes as operators. And our second project, which is our primary project that we're working on, is called Constellation. Constellation, in short, is sort of a layer 2 protocol on top of Rocket Pool. We've seen some of the challenges that Rocket Pool's had with scaling due to the bond requirements, and we think that we can leverage the entire Rocket Pool node operator base through our system to basically grow Rocket Pool far more aggressively, enabling it to compete in the market against projects like Lido. So this is a pretty large project, and we've been investing in it heavily. We're hoping to have that on testnet early next year with the mainnet release soon thereafter. So obviously it's very early days for us, but we'd love for you to check out our website, stop by our Discord, or you can follow us on Twitter and stay up to date. As for the future, like I said before, plenty of possibilities. We've been having so many fantastic conversations with teams here over the last 3 or 4 days, and we've been getting a lot of interest in partnering in the future. Obviously, we can't promise anything in particular, and even if we don't build all of these things ourselves, we're really looking forward to working with others as they begin to build on top of us in the future. So yeah, we're very excited.
So we believe in a totally cooperative approach because ultimately we all own ETH, or at least probably most of the people in this room and watching the stream. Everyone benefits when a project in this space succeeds, so we should make more projects succeed. If you saw that last slide and thought, man, I'd really like to have my logo on that list, well, I have some good news. You can. If you're a project looking for decentralized infrastructure to power your next great idea, we want to help you, and we would love to talk to you. And on the other side of the equation, if you're a node operator, you have really no reason not to join. You like earning more ETH. I mentioned this before. It's not a scam, I promise. I'm going to go way out there. If you're a dev out there that thinks, oh, I'm going to watch them and I'm going to fork it and I'm going to do it, awesome. Please, because that's what open source software is about. And the thing is that when we build something that makes the entire ecosystem more successful, everyone benefits. Remember, we all own ETH, right? So please, we want to talk to you. Doesn't matter who you are. It's really about prioritization, ultimately. We have a small team. We're trying to grow. So please, come talk to us.
And thank you for your time. Really appreciate it.
Questions?
Hello. How can NodeSet help Rocket Pool with the bond requirement and scalability?
Sure. So we are building some liquid staking tokens for that protocol. Basically, the node operator bond consists currently of 8 Ether and 2.4 ETH worth of RPL. The liquid staking deposit pools will ingest assets, existing node operators who we've onboarded and vetted. That way that they can basically spin up additional validators without having to provide.
One really nice thing about this that if you're technically heard of the nothing at stake problem, that's generally the issue when you want to scale something by just giving people assets and have them stake, because when they just grief it, and slash it unintentionally or something like that. The nice benefit of this system is that everything we're building is non-custodial. We don't build anything that's not a smart contract. So you'll know in advance, obviously, what you're agreeing to. But beyond that, operators have a lot more to gain by being part of the network and earning more in the future. And so if they were to get slashed, we have operators. It would just be a very, very tiny portion. And they don't really have a great incentive to do that unless they want to be really mean. And they would never be able to earn anything for the future. And like we've mentioned, there are a lot of projects on the horizon. So your earnings will grow over time. Many people say, oh, there's nothing at stake, though. But there is, actually. It's your future income. So to go against your own interests, then you can. But the network isn't harmed very much when that happens. So I felt like that's an impendum. A lot of people think, like, oh, you're doing something that should be illegal, right? But it's not.
Hey there. Congratulations. That looks really, really cool. So from that node, we're no strangers to free open source software that people can use to deploy whatever infrastructure it works. So definitely
let's talk right after. I didn't really know. I thought you were Rocket Pool guys. Why didn't we talk about this before? But
I've been meaning to find you actually for a long time. We talk to everybody and we can work with everybody, like I said. So
yeah,
it's back to back. But yeah, we'd love to chat.
Amazing.
That's how we met. We were originally Rocket Pool node operators, and we just thought, oh wow,
my question was when dealing with this type of software, you mentioned that you would like to cater to small node operators and medium-sized node operators, but we kind of find like the same problem. Every time we try to target a specific user or limit a specific user from using that node or incentivize a specific user from using that node, it gets quite complicated to make it not gameable. So what are your ideas in trying to limit the participation of big pools? Because if it's profit.
So this is something that I'm extremely passionate about, and I used to be a game developer. I know game theory really well. You're right, ultimately. So the only way to fix this is having a permissioned set of node operators. And so node set doesn't necessarily have to be a fully permissioned set of node operators, but it can be. So if you're a game developer, that example I gave earlier, and you only want to have small independent people operate with you, then you could visually permission these node operators yourself. One thing that NodeSet is doing for our constellation on top of Rocket Pool is we are independently verifying that these are, we're Sybil checking everybody. We're going through that whole process. Not every NodeSet has to do that. Some of them could be permissionless, but it's really that's the whole. The idea of the system is that it's highly flexible. So the person who wants the operators defines their requirements, and they say, if I'm willing to go through the effort, these people, ultimately you can't know if a Lido node operator signs up to your service and they just hide it from you, right? There's not really much you can do about it. Right. Yeah. Exactly. Yeah. But
there's one thing I'd like to add there. Our goal here is to scale horizontally as aggressively as possible, which means that the total allocation of validators per entity, ideally, and so for a large Lido operator, is it worth spending the time to try and game our processes and systems to 15 validators, 20 validators, maybe 15 validators across 4 different protocols for a total of 60 or something. And of course, they're only getting a sliver of the of the commissions. So, is that worth their time?
Even if they decide it is because they just want to do it, ultimately this is only for the validation side of things that we have this centralization concern, right? A really, really large existing operation can provide ZK proving services just as well as an independent operator. So ultimately, like I said, it's sort of up to the requirements of the individual application as to what they want to do to gate the node operator community. And obviously, services that we can provide is we do this sort of checking of individual node operators, and you can use that set if you want. We can go all the way from permissionless all the way through to crazy things. If you really need that for your large institutional ETF, I have to say that because that's the buzzword now, right? Whatever it is, we can help out with that, but ultimately you can also define those requirements too. It's a sort of what I'm saying is a non-answer, which is it's up to you as the application developer to decide what requirements you want. But we also aim to, from our position as people developing the tool set and products for this tool set first, give anyone who wants to build on top of it the necessary tools they need in order to define those requirements more explicitly. Account infrastructure that people can give us as much information as they want or not if they don't trust us, and that might be passed on to gate their applications and things like that, or not. It's really up to, and the key here is that we can't really step in the middle, and we reference this very briefly, but what we do is be another centralized point of failure for the chain. It needs to be something that accelerates everybody on both sides of the equation, and not something that is just another sort of thing that everybody has to be starting to be worried about, when we come to these conferences. Is NodeSet too big? We don't. we want to design away from that from the start. Yeah, it would be.
Okay, thank you so much. Next talk is at 1, so feel free to grab some food.
Hey.
Okay.
Yes.
Yeah.
Okay, good afternoon. Next up, I'm going to teach us everything about setting up test nets.
Yeah. Oh, wait a minute. There we go. Okay, great. Hi, everyone. I'm Galen. I'm one of the founders of Kurtosis, and Kurtosis is a developer tool that a lot of folks are using in the Ethereum ecosystem to spin up customized nets and test nets for consensus layer and validation testing. And this presentation is designed to be a follow-along workshop. It'll make the most amount of sense if you have your laptops out and are following along. We originally intended for you to actually install Kurtosis and run everything on your laptop, but never know if the internet is good enough, and the amount of Docker images you would have to download is about 6 gigabytes. So decided to do everything on Gitpod. So you'll just need a laptop and a GitHub account to actually walk through everything. So it's all about custom Ethereum devnets for consensus and validation testing. And first, we're just going to run a very basic testnet. It's going to have one full node only. It's going to be a Geth and Lighthouse pairing. And then we're going to move on to something a little more complicated with three full nodes. We're going to change the client between the EL and the CL layers. And we're going to show how we can have 128 different validators, because each node can have multiple validators. Then we're going to show you what it looks like to run with full PBS emulation. We're going to run the full MEV Flashbots infrastructure set. And while we're doing that, I will show you how it looks over Kubernetes. You're not actually going to set up your own Kubernetes cluster in this demo, but I'll show you that Kurtosis, you can run it over Docker, which is what most of these things are, over Kubernetes as well, without having to worry too much about changing anything. So, like I said before, what you're going to need is just a laptop and internet. We have the internet. Hopefully you're connected to the event internet, and a GitHub account. So to start, we'll run this via a Gitpod instance. So the URL is here. It's short url.at /g j s z and then uppercase Q. You can run into that Gitpod instance to open up Kurtosis. We also have a bunch of Kurtosis team members around the audience to help out if anything is going wrong, going poorly. Just yell at them and they'll handle it. So I'll leave this up here again and repeat it real quick for people who might not be able to see it too well up here. It's short url.at /g j s z uppercase Q. Give a little bit. Show you what it looks like here inside of that short URL. Great. Great. You should see something like this. It might prompt you if you want to submit your email address. You don't just, if you hit enter with nothing, it'll be fine. That's optional. Let's see what if my connection's working here. go. Okay. Is anybody still waiting for a screen that looks something like this to pop up? Got one? Cool. The very first thing we're going to do is we're going to run it's called the Ethereum package. The command is going to look like kurtosis run github.com/kurtosis -tech/Ethereum -package. It's just going to look like that. I'll try to zoom. I'm going to zoom in a little bit here. Let's see if it works. Oof. There we go. It looks something like this. Kurtosis run github.com/kurtosis -tech/Ethereum package. So the way Kurtosis works is environment definitions are in things called packages. And a package kind of contains all of the setup logic that's involved for spinning up, in this case, an Ethereum testnet. And with Kurtosis, you just point it to a GitHub locator, and it's going to pull everything it needs from that GitHub locator to spin up what you need. So when we run this, interesting. I lost my Kurtosis. Let me see. Sick. Hopefully that didn't happen for anybody else. I'm going to blow away my workspace real quick and then do a new one. Oh, geez. Boop, boop, boop. So to repeat that command here, it looks like, assuming your workspace worked and mine didn't, kurtosis run github.com/kurtosis-tech/Ethereum-package. Is anyone attempting to run this and not able to do it or hitting problems? Awesome. Apologies while you're doing that. I'm going to keep reinitializing my own Git pod here. Now what you should get out of running this command is you'll see an output that kind of lists all the things that Kurtosis is doing. It's spinning up an EL client, a CL client, a bunch of helper services. It's putting the Genesis data where it needs to go. It's getting you the validator keys you need to get. And it's going to do all that stuff. And at the end, you're going to see a bunch of an output that tells you all of the stuff that's available. And you should see, if you're in Gitpod, you should see a list of URLs. And the URLs are port exposures. So any relevant application ports, including Explorer front ends and all that stuff, they're going to be available to you on your local machine. If you're in Gitpod, you're going to use the Gitpod port forwarding, and it's going to work fine. And I think I am almost back on track here. Yes. Okay. All right, hopefully this one's going to work so you can see it live on screen here. All right, so you can see it's downloading all of the Ethereum relevant images. It's going to need to download fpanda ops python web3. You have some observability tooling and some spammer tooling. Spammer, what I mean is like transaction fuzzing and like sending activity through the network that's kind of just basic activity, so you have some degree of transactions to work with. Grafana, Prometheus, and a couple different explorers. This, the entire package that we're running, by the way, on GitHub is an open source asset. I'll show you where it is on GitHub. It's an open source asset that is jointly maintained between, I'll show you, between Kurtosis and a couple of folks in the Ethereum Foundation, Pari, Barnabas, PK910, SamCM, and we have contributors from across client teams and different block builders that have contributed to this. So it's a community effort that's still growing, and as you get comfortable with it, you can also become one of the contributors or maintainers. So back to my Kurtosis that's running now with the default configuration. As it prints, it's printing out all the stuff that it's doing. It's showing me exactly what Kurtosis is adding as it's adding. And then here's the view that I wanted to show you earlier. You can see that I have port bindings exposed everywhere. I have a CL Lighthouse Geth service, and what that is that's represents the Lighthouse node. And then I have the beacon chain kind of part of Lighthouse, and then I have the validator part of Lighthouse, and then I have the Geth node. And the RPC ports are exposed, and I can show you that Dora, which is a lightweight explorer, comes with the whole system, and you can click into Dora, and you have a nice explorer for your testnet. We are currently pre-Genesis. You can see that the Genesis is going to happen in 34 seconds here. So we're not going to see much activity yet, but once Genesis happens, you're going to start to see slots come through, and you will also be able to go to your validators screen, and you'll be able to see all of the validators that you've deployed in your network. There's one node running here, but each node has 64 validator keys tied to it, and that's why you see all of these entries here. Yes. Great. Does this make sense so far? Is there anybody still working on this step? And if not, we can go to something a little more fun. Gianni. Cool. What we'll do in the next step is, and this is one of the big benefits of using this package that we've built, is you can pass in a high-level JSON configuration. JSON configuration will specify things like CL client pairings you have in your network, how many instances of each ELCL client pairing. You can also specify additional services, like more advanced explorers or like the MEV infrastructure. So to start doing that, we're going to do something a little more complicated. So if you can go to this GitHub URL, it's github.com/kurtosis-tech/summit, and once you're in called complex.yaml. That complex.yaml is a starter configuration file for something that's going to be more exciting than what we just saw. And then once you have that open and on your machine, or in your Gitpod, then we're going to change it together a little bit. So github.com/kurtosis-tech/summit, and then go to the complex.yaml. And in just a second, I'm going to move my screen over to go to GitHub to show you where that thing is. Cool. github.com/kurtosis-tech/summit. And once we're in there, we have complex.yaml, and you can see a YAML configuration that this is going to give us a different testnet. And you can see that there is a Geth Lighthouse pair, a Nethermind Prism pair, and a Reth Teku pair in this testnet. So 3 different nodes. And we also have a couple of different additional services specified. Here? Yes. Yeah, that's good. Yeah, it's going to be easiest to be able to copy and paste this because I'm going to move out of the screen just a little bit to show you what we're doing. But let's make, in Gitpod, let's take this and let's make a file. Let's make a file here called complex.yaml. Keep it simple. And then let's paste the contents of the file in GitHub into that complex.yaml. Here. Cool. Now once you have that, is there anybody who's still getting to this spot? Great. Give a little pause. And if you're curious, as we're catching up, if you're curious about what the exact options here for this YAML, this JSON are, if you go to the Ethereum package in GitHub, you can see a full spec. Oh, where is this? In the editor. Here? Oh, there's a typo. Let's see, is it everywhere? It is. Okay, on line 9 of your YAML, if you see network, that's not a word, it's going to be network, network underscore params. Yes, thank you. Ah, that's why I didn't catch it. Got it. Got it. Cool. Network, net W0, O, RK params. It's going to work. Cool. And now, so with this as the base, what I want to do is I want to edit this a little bit together to make some changes so you can see what it's like to do a little bit of configuration on your YAML. So on line 8, we're going to set this key. We're going to set this key Ethereum metrics exporter enabled to true. On line 10, we'll change the number of validator keys per node to 128. And then on line 11, under additional services, we'll add the following. We'll add full underscore beacon chain underscore explorer. And that's going to give you a more advanced explorer than what we saw with Dora. It's a little more heavyweight, but it's going to have a different set of visualizations that is going to be nice and useful for you. So I'm going to pop back and forth now as I do this too. So Ethereum metrics exporter enabled. I'm going to change this one to true on line 8. And then the next one is changing the number of validator keys per node to 128. So what I'll do is go to number of validator keys per node, change this to 128. And then also under additional services, I'm going to add a new additional service, and it's going to be called full underscore beacon chain underscore explorer. Full, like this. Make sure I got that right. Full underscore beacon chain explorer. Okay, this makes sense. And now we can go to our terminal. Pull this up. And we can run kurtosis, run, it's going to be github.com/kurtosis tech /Ethereum package. And then we're going to have an additional command line argument, --args file. And then you're just going to pass in complex.yaml, which is the args file that you just created. And if you run that, then kurtosis is going to take in those arguments, and it's going to change the setup of your testnet. You don't have to stop the previous one. They can run simultaneously side by side, and you should be okay. So it's going to download a couple of new images that it didn't have before because we've added new EL and CL clients. We've added a new Explorer. So we're grabbing a couple of these images. This is the main reason why we're doing it on Gitpod instead of on our own laptops, because this would have been a nightmare over spotty internet to try to do all at once. And it's going to do the same thing it did before. The thing that it's printed out is called the plan. Every Kurtosis package creates a plan, and the plan is a sequence of steps that are kind of the fundamental building blocks of spinning up an environment, a multi-container environment. So that's what it's spitting out here, and it's a bunch of stuff that handles the DevOps complexity involved in passing all the different values involved in setting up one of these testnets between all the nodes so that they have all the information they have to have in order to start up. Great, now we're starting to get the Beacon Chain Explorer, and while I can give a shout out, I believe the Dora Explorer was built by PK911. Hey, yes, thank you for that. He's in the audience, we can give him, thank you, it's awesome. And then Beacon Chain was B-Chain, no? Awesome. So that's what we're gonna check out here. We're gonna check out the Beacon Chain this time. The previous one we saw was Dora, which is still running. It's great. Great, we're almost to the end of this. Let's see. Great, okay. Let me just make it a little smaller so everything fits into this spot. Okay, so now we got a bunch of services. I mentioned we have a bunch of different EL-CL pairings here. And all of their most important ports are exposed to you in your local machine so that you can play with them. We have now a new exploration tooling available via the Beacon Chain Explorer, and if we go to that front end, you can see Chain UI. As before, you can check out your validators and you all the public keys. In this view, we don't see what type of validator they are, like whether it's Lighthouse, Geth, Lighthouse or Geth pairing or like Teku Prism pairing. Like these things are going to be not immediately available in this view, but you do have a different view for your transactions and for your mempool slots. Now it's very. We're on slot 9 here apparently. Cool. Another thing that I wanted to show is that we have built-in Grafana and Prometheus dashboards in these testnets. So if we pop into Grafana, I'll show you a bit of the dashboards the community has put into the package so that you can get some monitoring out of the box. So let's pop into the dashboards, general, and I'll show you we have the Ethereum metrics exporter overview, and it's split into, real quick, I'll collapse these real quick. It's split into an overview, the consensus layer, and execution layer. It's split into consensus spec, overview, consensus layer, and execution layer. And as you dig into these, you get kind of the sets of monitoring that you would expect. Head slot, epoch. I believe in the overview we have memory usage and CPU usage per node, and you can use this to check what's happening as you run your tests. That's the Ethereum metrics exporter overview. It has the aggregation of all these different validators together. There's also another dashboard, which is a single view, where you can actually pick the pairing that you want to look at. And then when you're in that pairing, you have a more in-depth view per node. So just quickly to review what we just covered, when I run the testnet, I have a couple of things. I can configure the ELCL pairings. I can configure how many of each pairing that I get. And once it runs, I have a flexible selection of explorers. I can use Dora the Explorer to start. I can use the Beacon Chain Explorer, which has a bunch of different services that are involved in getting the thing going, but it has different views that I can use. And then when I want to do my observability and my metrics style stuff, I have Grafana, and I have a couple of dashboards that show me per views, either on the aggregate or per EL or per CL client. Cool. Now, things I'm going to show, one of them we'll do together. The other one I'll just show you while that one is running. But before I move on, is there anybody who are getting up to this step, or am I good to move to the next spot? Great. So the third thing we're going to do is we're going to run the software in the testnet as well. So the first thing I want to do is I want to run kurtosis, move the stuff that I've already ran. It's going to free up some space for me to run kind of a more head here with the flashbot stuff running. So going back here, kurtosis clean-a, it's going to wipe away all of the containers and the files that were generated in the creation of these testnets. It's going to clean up both of those things. Great. And now what we can do is we can go back to the Summit GitHub where we have the configurations, and we can go to mev.yaml. And in mev.yaml, we have a different setup where we've configured a full mev to be running, and we've also configured some parameters that are, one, going to make it, I think, move a little faster for the demo, and also going to set exactly which images are going to be used for mev flood and for mev relay. So if you can pop into that GitHub and just copy and paste that into a new YAML inside of your Git pod called mev.yaml. And this one doesn't have a typo. So pull that mev.yaml. And this one we're not going to edit together. It should work just the way it is for what we want. And then all we'll do is we'll run a very similar command as before. Kurtosis run github.com/kurtosis-text/ethereum-package --args file in order to specify the args file. And what I'll do is instead of running complex.yaml, I'll just run mev.yaml. Cool. Now this one is going to take a hot second to run because I want to show you mev working, and it's going to take a couple of epochs in order for that to happen. So so that's gonna run, and while that's running, I'll show you how to do stuff over Kubernetes, and hopefully by the time we're done with that and we get back, then everything will be clean and good to go with this. Real quick, just to check. Great. Okay, I'll pop over into Kubernetes real quick to show you what it looks like. And I'm going to do this on my own laptop. So just to show you, Kurtosis runs not only in Gitpod, but also on any laptop that you bring. And Kurtosis, it runs over... It can run over Docker or Kubernetes, and the way that you choose between these things is with the cluster setting. So if I was to just set my cluster to Docker, let me make sure my gateway is not running. Yes. So if I set it to Docker, then I'm running over my local Docker engine, and if I set it to remote Kubernetes, then I'm running over a remote Kubernetes engine. And the way that works is in my kube control file, I have a remote Kubernetes cluster set up. So I did that beforehand. That's why I can just type this. But what you would do is you would make sure that you have your kube control on your own laptop configured to your remote K8s cluster, and Kurtosis will just use that to connect to it. So now I'm on my remote K8s cluster. I'm just going to run one more process here. It's called Kurtosis Gateway. And Kurtosis Gateway enables port forwarding from everything running in Kurtosis into my local laptop. It'll just make the user experience a lot nicer, and I'll feel the same thing that I saw before, where all of the important ports that are running inside of my Enclave, which is the testnet, those are all going to be mapped towards my local machine so that I can access them and do my workflows there. So now that I'm on, let's see, Kurtosis, just to make sure, Kurtosis cluster ls, I am indeed on a remote Kubernetes, and then I can run the package exactly the same way that we saw before. Kurtosis tech / Ethereum package. I can run it exactly the same way as before, just pass in the GitHub locator, and I'm gonna have the exact same user experience, but instead of the deployed target being Docker, it's gonna be Kubernetes on the remote cluster. So it's gonna show me the same exact thing, the steps that it's doing as it's spinning up my network. And then once we get to the bottom of it, it's gonna show as well the list of services that are in the network and the local port mappings. And just real quick, I'm going to check the progress on, yes, MEV. Mm-hmm. Yes, yes. And my CTO is here as well, so he can give you some more detailed answers. The short answer is that right now, the administration of the K8s cluster is completely handled by the end user, and the extent to which you can do very customizable things are inside of the Kurtosis package. You can specify per thing, per service, and then you can also specify custom labels, and that's how you would do stuff like flows, because you can specify the labels that get tagged into things, and then your other systems will pick it up. And we're working on persistent environments, so these are designed to be ephemeral. But we're working a lot on the persistent use case, and Kevin might be able to give some better details on that.
The balance we're trying to strike is not exposing an overwhelming amount of config, so be making the abstraction useful, but also giving yourself an escape hatch in order to get down to being able you might need. So the balance that we have right now is being able to specify min and max resource limits, so CPU and memory. You have to do affinities and taints, so being able to specify which node that you want to get allocated. We're looking at that now. What would be a good design for that? Something that's not going to overwhelm the user. And then beyond that, like for example, being able to inject service meshes and stuff like that, we don't have that ability yet. It's something we're also So the question was, what about Terraform? Yeah, so we would, a way to use Terraform to automate all of this would actually be that you use Terraform to call down to Kurtosis. Knows about all the resources and everything that you're being able to spun up. If you want the very low level control, then Terraform Kubernetes resources, Kurtosis is not going to be a replacement for that. So if you need like very deep control, the idea is that we're trying to provide a much more user-friendly.
It looked like you had different kind of clusters that you could set with like Kubernetes and local or Docker. I mean, would it be possible for someone to contribute the roster configuration?
I can take this one. Yeah, yeah. So one of the question was how difficult would it be? It would definitely be a not, but two of the ones that we've contemplated is maybe a bare metal cluster backend, and then potentially a HashiCorp Nomad. Either of those we don't have plans. The bare metal one we're kind of exploring a little bit, but we don't have that yet. But it would, like, you can go to the repo on GitHub and check it out.
And what these values are, you can put these clusters onto this setting. So you could have 8 of them if you have 8 of them. That's very much a user set thing, but right now at least it has to be either K8s or Docker. Yeah. So like I said, just to close the loop on K8s here, but it is mapped to my local machine, just like it was earlier over Docker in Gitpod. So I still can like click through, for example, to Dora, and we're gonna see Dora the Explorer, and Dora the Explorer is gonna show us, the slots and the validators that we would expect to see. Well, and then the same thing works as well. If I want to clean up everything, just get rid of all of those containers and files in my Kubernetes cluster, I just run kurtosis clean-a, and it's going to clean up all that stuff, and my K8s is going to be clean from the stuff that I put there before. Let's pop over and see if the timing worked out favorably for my Gitpod. Oh, here we are. Great, timing did work out favorably. So my MEV flow has ran, and I have a couple of services here that are related to the Flashbots infrastructure, MEV Flood, MEV Relay API, Housekeeper website, all of this. Now if I click into the MEV website, this is where I'm able to see whether payloads have been delivered from the Flashbots relay. And we haven't had any payloads, and if we want to see perhaps why, we can pop into, I guess Dora is going to tell us. 28 more slots? Let's see. We are on the 3rd epoch. We need the 4th epoch, so 50 more seconds? 84 countdown together if we want to. While we're waiting for that, let me just pop into the presentation real quick. Let's see. Yes, so just to recap the stuff we saw in Kubernetes while we're waiting for that to happen, we have people using Kurtosis to deploy these test nets on Kubernetes, and then using Chaos Mesh on the same K8s cluster to do chaos testing. There was a tool by Trail of Bits that was showing that at the TrustX talk yesterday to reproduce a finality incident that happened last year on mainnet. And you can do a lot of other stuff there. And it also is useful for doing stuff at higher scale, of course. If you're going to do it remotely, you can scale it up, and K8s will handle all that for you. Great. We're on the 4th epoch, and if we go to Flashbots, let's see what we got for the boost relay. We're starting to do payloads. Yes, so we have Flashbots actually delivering payloads to the network now that we are on the 4th epoch of our beautiful testnet. Great. Now that is it for the workshop. You can open it up to flexible questions if you like. And also, we have a QR code so you can scan it and get to the Ethereum package. I imagine if you wanted to go there, you've already gone there probably over the course of this. But the Kurtosis folks are all in the crowd. Yes.
So how useful would you say is it? testing, think hard hat or Enclave, for example, in the Foundry stack. How useful is it, or like, is it possible to add those into this stack and kind of have like a both consensus layer and execution layer testing suite kind of combined? I know that there's probably a lot of trouble with hooking that stuff up to each other, but maybe you have ideas.
Yeah, I think a lot of the execution stuff works really, really well with like basically like EVM simulators and people that really focus on the EVM testing side of things. So I haven't yet seen like EVM style or like DApp layer testing working well with kurtosis. The way I would do it is I would try to combine those tools into the network to the extent that any of those tools can connect to like full nodes that then have different consensus layer configurations. The other like place is if you're doing things with like oracles or other like side services that you would want to have hooked in to a full node, and you want to see how that thing changing impacts how your smart contract is moving, because then it's like more realistic. Cool.
I'd love to hear.
So basically, entire hive tests, which are being spin up on every release, on every testing phase of the EL and CL, are using kurtosis as well. So the kurtosis is spinning out the local testnet, and transaction spamming is happening, and plenty of thousands of tests are being devnet, each before shadow forks, etc. So this is like highly appreciated for us. And on the other side, which I'm doing right now, we are helping Flatboot's team directly about comparing two versions of builders, testing the performance, and we are in kurtosis, and we help. We get tons of help from the kurtosis team about the AMIF flat. So we are using it at it's already starting to help the Flatboot team about UPRs, and Builder Star is open source right now. So this would be some kind of improvement, like performance comparison of the latest version comparing to the PRs, which will be pushed to the builder. So that's the current use case which we are like closing up this week. So those are the things.
And I can add one more comment on this. So it's designed to be written in a dialect of Python, and you can import packages into other Python scripts and then build extra stuff on top of them. So basically, you can say, hey, like slam together any bits and pieces that you want to form new packages. So if you wanted to add something on top, add an oracle, or maybe like add a DApp server or something like that, totally do that.
Let's thank the speaker again, and thank you.
Şu an nasıl? Kabloyu değiştirdim. Daha mı iyi abi? Ha, tamam. İnanıyorum abi, sana bir şey demiyorum. Ah, hey. Tamam. Açık bu arada abi. Ben bunu çok sonuna kadar açık. O yüzden bangır bangır geliyor olabilir. Ben biraz kısayım o sesi sana. Çünkü sonuna kadar açık bütün her şey. Sen onu dinleme durumun var mı abi? Diğer gelen kanalla aynı hizaya getiriyorum. Tamam. Şu anda nasıl abi? Ya eşit olması gerekiyor. Eşit değil mi? Tamam. Ah. Seslenme 1 2 3. Sound check. Ah. Onu yükselteyim mi? Ah. Şu an nasıl abi? Yükselttim. Ah. Abi öyle çok
Bekle, o kendi oradan ayarlar.
Şu an son.
Şeyden de gönderiyor musun bunu?
Diğerinden alt altıdan da gidiyor.
Yok, var da abi, sana payım var Mehmet abi. Yok, sana gönder. AUX 2 değil mi?
Aynen.
Gönder abi hepsini. Nereden
Böyle daha kötü gitmiyor mu abi ya?
Bekle abi.
Mehmet abi şu an nasıl? Her şeyden sonuna kadar gidiyor. Master'dan da kendi fader'ından da. Tamam.
Çektiğin ne? Kaça bağladın? 6'ya mı?
6 da abi şu.
Bekle.
Şunu bir aç. Şu an da eşit aynı. Yani ikisi de sonuna kadar açık geliyor. Ama şu an sesi duymamız gerekiyor abi. Patlayan bir ses de gitmiş olabilir. Hani biz sonuna kadar açtık master'ları.
Tamam, o sıkıntı değil. Şu anda o oradan...
Tamam da abi bu ses yayına gidecek şimdi.
S, A. Bak sabah böyle geliyor muydu? S. Çünkü sonuna kadar açtık. Pazartesi, salı, çarşamba, perşembe, cuma. Mikserden açık şu an sonuna kadar. S, A, hey, hey. İkisini de mi abi? Yo bir dakika. İkisi de sıfırda şu anda. S, A, 1, 2, 1, 2.
Yes. Hello, everyone. I would like to introduce our speaker. It's Ladislav. He's a longtime member of the Staker community, and today he's going to be talking to us about. Take it away, Ladislav.
Hey, everyone. Thank you very much for coming. My name is Ladislav, as Nolan said. Thank you very much. I'm a member of the Staker community, and I'm very humbled to about validating from hardware enclaves. Please take in mind, I'm everything but a computer. Take everything what I say here with the appropriate grain of salt. I'm simply reporting back sort of my experiences when tinkering and testing and using those tools we're going to talk about today, and sort of give a high-level overview. And it takes about, let's say, 15 minutes, and then I hope we've got some time for questions. So quick recap to get started. We're talking about validator key protection today. And yeah, of course, to avoid common slashing risks. And validator key protection is not trivial. So I've brought up here this iconic diagram from the fine folks from Attestant, basically showing the different layers of protections for validator keys. Not a lot has changed since this has been published. So basically, we start at the nucleus, right, with sort of the default of protecting keys. Meaning they have to be hot on disk, right? You generate your key store and then have an attached to it passphrase, and then the further out you go, the security layers, if you will, then you sort of reach at some point maybe the separation of concerns between a validator client and your remote signing software, such as Web3 signer by consensus, and even further out, you could sort of add some more cryptographic, advanced cryptographic primitives like DKGs, threshold signing, and basically enter sort of the DVT distributed validator space. But the key here is, right, we usually have like this key hot on disk to show up for consensus duties, right? And sort of what we are going to look at over the next few minutes is sort of this in-between layer, as you could say, where we would try to put a remote signing software inside a hardware enclave. And so sort of the TLDR to sort of make you aware of and what validating from hardware enclaves even means is think about your generic hardware wallet and which stores your keys, like you generate a key inside this hardware wallet, and basically what we add on top of this is program logic. So we add some smart functionality here, and this is, in our case, slashing protection rules. So what we get is this nice system where we have protection not only at rest, but also at runtime. And sort of also what's nice here is it's really tough, or we get a system where it's really tough to exfiltrate the generated keys inside, but still are able to perform consensus duties from it. Right, as shown here, proposing blocks or testing to them. And so the original idea to do so stems from this ETH research post by Justin Drake, where he basically proposes hardware-based slashing protection for liquid solo validating pools. And just to give you a very brief idea, like what are the properties of hardware enclaves? Like what are we talking about here? So on a very, very high level, like we have to think about hardware enclaves, or the specific hardware enclaves here, as some form of isolated, encrypted areas of our CPU memory, which are supposed to be like untemperable, and sort of we trust the code execution inside it. So what we receive as users is some form of confidentiality and integrity guarantees on the code and on the data running inside those enclaves. And basically the underlying hardware itself sort of ensures that those properties hold. And just to briefly contrast this from multi-party computation systems like DVT in a sense, or more advanced cryptographic primitives, we get this, it enables us to sort of run arbitrary and very inexpensive computation, almost at the native speed of the CPU, which is in the staking context particularly interesting, as sort of latency is a critical component, right? So what I want to introduce today to you is this software called Secure Signer. Secure Signer is this open source validator remote signing tool, adapted to be run inside trusted hardware and inside hardware enclaves. It's written in Rust, has been originally funded by an Ethereum Foundation grant, and the Puffer team, Puffer finance team went on to develop this tool. And basically what it is a Web3 signer implementation, adapted to be run inside hardware enclave. So simply what it does is sort of you have your hardware enclave, and then you instantiate the enclave with a remote signing program logic running inside it, and what you also store and generate inside it is the validator keys themselves, plus the slashing protection database. And sort of it makes you communicate then, of course, in a secure manner with the rest of your node stack. Yes, and the underlying hardware technology we're using here currently is Intel SGX. But then, of course, initial question that arises is, what is secure about hardware enclaves anyways, right? Intel is a centralized entity. The tool we use here, or the functionality we use here is proprietary, it's closed source, it's been subject to vulnerabilities in the past, so the memes are obviously bad. But then if you look around a little bit in the blockchain space, you realize like that teams like Flashbots, for example, heavily lean into SGX for their encrypted mempools in Suave, for example. We see block builders being run inside SGX hardware enclaves. We see liquid restaking pools like Puffer sort of using trusted hardware to lower the trust assumptions in node operators. Plus, we see it in ZK land, for example, with multi-proving and multi-verifying systems opting for SGX as the technology. So at the end of the day, it seems to boil down to like trust assumptions of users and sort of the teams developing this. And obviously, from a staking perspective, it boils down to your subjective threat model. So if we were to make an argument for why we should would want to validate from hardware enclaves, we could think of them as a simply purely additive ring of defense, like an additional layer to secure our signing keys. Moreover, trusted hardware is widely available, right? Everybody from us can get a hand on it if we wanted to, despite the fact that Intel has sort of deprecated SGX from the consumer products lines 2 years ago. On the server side, it's still widely available. And last but not least, using remote signing software in a diverse manner. So we increase our option space and sort of make our network potentially more robust in a sense. And very specifically, like node runners, what specific risks that node runners can sort of mitigate and potential benefits for them look like could be as follows, right? As you generate a key inside a hardware enclave, it only ever exists once within a unique enclave. So it's not possible to accidentally equivocate or double sign, particularly for home stakers or keys protected not in data centers. It's interesting that like as you're protected against hardware wallet theft, like the mechanisms in place there also apply to keys stored within SGX enclaves in this case. Think of a critical consensus client bug, introducing like potentially faulty slashing rules. Like as you run untemperable slashing rules inside a hardware enclave, you're immune to such failures. And last but not least, you avoid any sort of slashing risks as a consequence of a potentially compromised node or a client accessing this node, right? So you're immune to kernel level malwares, for example, operating system 0 days, rogue staking provider or cloud provider employee scenarios, etc. And what's pretty cool about it, it's solo staker friendly, right? You don't have to be an at-scale operator to use this technology. So that's basically what I did, what I wanted to test. So I got myself this slightly outdated piece of hardware, which is a NUC, right? SGX compatible. And for the sake of the demonstration, I wanted to run the whole client stack on this underpowered device. So I tested this on Ephemery testnet. Ephemery testnet is this neat little short-lived validator testnet, which basically allows you or has very low hardware requirements. Since it resets every week, so there's not a lot of block history or state history. So yeah, it fit nicely in my testing environment. And then of course I use some Docker Compose script to sort of run my execution client, consensus client, and validator client, and sort of the secure signer, my client interface on the untrusted side of my NUC. And then from there instantiated sort of secure signer, the tool, inside the SGX Enclave, generated my key pair inside it, generated my deficit data file inside it, generated my voluntary exit message inside it, and made it securely communicate with the rest of my node stack. And right, so no staking gathering without looking at logs. So what you can see here is basically the secure signer log file telling us that, or showing the log that we successfully attested on Ephemery testnet at a given slot in a given epoch with a key stored and generated inside trusted hardware, inside a hardware enclave. So ta-da, right? It works when mainnet. Will still take some time. So Secure Signer, the tool, is still has recently been released, right? It's still in alpha. Codebase is still being worked on. It needs review. It needs audits. There are some UI and UX improvements we need. Feel free to get involved if you want to. What would also be nice is to get hardware vendor diversity, right? We don't want to rely on Intel, so it would be great to have AMD support at some point in time, or I know that there's work to enable support for AWS Nitro, for example. And then in terms of an outlook, the usage of Secure Signer is complementary with DBT. So as you can guess, you don't only have to necessarily have to store a full key inside a secure enclave, but you can store fractions of a key in it as well. So if you think back to the original diagram, we can sort of think of adding or running or validating from hardware enclaves being like an additional layer even around distributed key systems. Yeah, that's pretty much it. That's the long form read of my experiences testing these systems. It's also included as a step-by-step guide on how to set up the testing environment I just showed you. Yeah, don't worry, you don't have to necessarily own or have SGX compatible hardware at hand to test this, right? You, in a dummy mode, sort of Secure Signer can run on as a pure Rust app in your setup as well. So feel free to test it out, and yeah, shoot me a message if you want, and happy to take questions.
Thank you so much, Ladislaus. Hi, thank you. Two questions. One is that, is it the same as HSM? And the second question is, you mentioned the network which gets reset every week. What was the name again?
Okay, second question, it's called Ephemery testnet, and this is a public Ethereum testnet. There will be a talk by Mario later this afternoon, so I suggest you to stick around. And the first question was whether this is an HSM. So HSM stands for Hardware Security Module, I guess, which is, as far as I know, again, disclaimer, I'm not a computer security researcher, but the hardware enclave or secure enclave, but not smart, right? So you only store your keys at rest in hardware, as far as I guess. So Intel SGX is basically this technology with widens, in very simple terms, sort of wide functionality to run program logic also inside a secure env, right? So it's not just about data storage, it's about trusted execution.
Any other questions? No? Okay, well, thank you very much, Ladislaus.
Appreciate it, thank you.
Test, test. Non.
Mirror, no. Full screen. Full screen. 1 minute. Full screen. This presentation. Yes. No. Yo, no, 1 minute. Yes. Screen.
Tamam.
Yes. Haha.
Good. Teşekkür ederim.
Rica ederim.
Hello, our next speaker. This is Lanxi from DAppNode. He has a proposal on how to overcome the limits of solo staking.
Thank you very much. How are we doing? Okay, so you have 5 minutes to go to the main stage where there's Alex Stokes with a fascinating call about MEV. If you're staying here, you're either a Lido or you know me. So so appreciate you being here. Okay, so taking decentralization beyond. When I talk about borders, I talk about borders quite literally. Before we can move on to decentralization, I think it'll be good to do a big refresher of what decentralization is, because we can sometimes get lost about what's important about decentralization, whether centralization has value in itself or decentralization is a means to an end. Well, decentralization, I like to see it as a gradient with emerging properties. What does it mean? It means that if you have a system that's designed for Byzantine fault tolerance and all of these fancy words that we have for decentralized systems, but you have only one node, you have a centralized system. You have one single point of failure, you have one database, we have no redundancy, so you have basically a centralized system. If you happen to have 2 nodes in that system, you got some very, very basic type of data redundancy. Those 2 nodes could be, for example, maybe in the same house, in the same data center. So you get like some sort of data redundancy, but not decentralization yet. If you have these nodes in different locations, all of a sudden you have resilience to natural disasters. This is an emerging property that emerges by the fact that they are in different natural natural areas, in different areas. If you have nodes in different power grids, you are resilient to the power grid going down. If you have nodes in different political jurisdictions, you are resilient to government interference, meaning that if a government in one of these jurisdictions want to tackle or attack your protocol, you don't care, it keeps running, the protocol keeps running because it's in more places. Nodes in different type of hardware means that you have resistance to hardware vulnerabilities, zero-day exploits, etc. Different client implementations. Why do you think we have Prism, Lighthouse, Lodestar, Aragon, Geth? If there's a bug in the implementation of one of them, the protocol will still keep going. And then we have like system-specific properties, right? Like validator ownership, what is the hash rate concentration, you have different needs for bandwidth, you have the storage concentration, if it's a system that is very dependent on storage, like IPFS, Filecoin, these sort of systems. And this is nothing new. This is not new from the centralized systems. This is a concept called CMF, common mode failure, which in aerodynamics is used all of the time. If you have a plane and you only have one sensor that detects temperature and the sensor controls a crucial part, if the sensor goes haywire, the whole plane goes haywire. So you need to have different types of sensors, etc., etc. This is not new to the centralized worlds. All right, we know what decentralization is right now. We have like a good understanding and a common language, a common base to start the discussion. So let's talk about solo staking. Who is solo staking in here? Who has a validator? Good, okay, we're like 2 people in the room, so 2 of them staking is good. No, I'm exaggerating. Solo staking is considered the gold standard of decentralization. It's not the gold standard of performance. It's not the gold standard of economies of scale or cost efficiency, but it is considered the gold standard for decentralization. And we have established why decentralization is good because of this previous slide, right? So, solo staking works in any country. Anybody can use it. It works with different ISPs. It works with different power grids. And it is small and nimble. Solo staking favors small and nimble
setups. It favors variety. One node caters to very few validators, so if one node goes down, the person who runs this node will be affected, but the network as a whole won't care that much. So it's very resistant. It contributes a lot of value for the network. Downtime is irrelevant for the network, and your node going down is not a point of failure for the network. And that's why Ethereum is designed to be very, very permissioned, very, very permissive with these sort of setups, meaning that the downtime is not penalized a lot. And what is penalized is correlated penalties, meaning that if you have a big operator that goes down and thousands of validators go down at the same time, you get correlated penalties and you get a big penalty. This is meant to disincentivize centralization. Right, so where has this get us? Where, like, we have a system that favors decentralization, that favors solo staking, and it has gotten us to more than 800K validators. That's a lot of validators. And in 13,000 nodes in more than 85 countries. So overall, having a protocol that's geared towards favoring solo stakers in some sort of way and disincentivizing big actors has served us well. But let's dig a little bit deeper on what are the limitations of solo staking. How many of you know what the Nakamoto coefficient is? Nakamoto coefficient? No one. That's right. The Nakamoto coefficient is the number of entities that need to be compromised to compromise the network, right? And the Nakamoto coefficient, sometimes some Puritans, like the Nakamoto coefficient can be decided for many, many different vectors, many different verticals, like how many countries need to go down, how many machines need to go down, how many entities, how many owners of the network need to go down. So tell me a number about the Ethereum network. What do you think the Nakamoto coefficient is for the Ethereum network? How, like overall, if we take the worst case scenario? Very optimistic, 4 or 5. Very optimistic. More than a third of the nodes are in the United States, and more than 50% between the United States and Germany. So this is geopolitical Nakamoto coefficient, and that's why I mentioned this. It is not necessarily a logical or a architectural Nakamoto coefficient. It's a geopolitical Nakamoto coefficient, and it is of 1. We don't finalize if we have the United States going black for whatever reason, right? And if United States and Germany go black, then we don't have Ethereum anymore, basically. So solo staking has served us well, and this is arguably a very, very, very unlikely scenario, but it has limitations. Why this concentration in these countries? Well, these countries are countries that have disposable wealth, meaning that people can take risks with their money. Cryptocurrency is still a very risky affair, and people in rich countries can afford to invest on cryptocurrency and put 32 ETH in there. There's also a lot of availability of information in English, and rich countries tend to use English as one of their main languages. Most people tend to speak English and be able to read this information. Cryptocurrency evolves very fast, and information often is only available in English because it's produced in English, and by the time it's been translated to another language, there's already a new paper in English that disproves the first paper, so to speak, or a new EIP, or a new discussion. The evolution of it happens in English. And finally, the rich countries have trustworthy internet connections and power grids. So we have the concentration. So people tend to trust their validator setups a lot more if they are in rich countries. Now, solo staking has limitations, but traditional pools are not going to help us because they're based on the same countries. We have Lido and Coinbase having more than 1/3 of the Ethereum network. So the Nakamoto coefficient when it comes to entities is of 2. Now Lido over there will tell me, yeah, but Lido, what can Lido do? What can Lido, like it's very secure, it's different validators. Sure, but politically they are still controlled by 2 entities. And if there was an all-out war on crypto, that would happen. I hope it doesn't happen. Now a little intermission of why am I talking about solo stakers and why am I bashing on solo stakers on a solo staker conference? Like I'm not, I swear I'm not. Yeah, there we go. I made them freak out with this. It's me. It's my it's my slide. Yeah, so Devconnect so basically why I'm bashing is because I think we can overcome these limitations while we're making Ethereum even more decentralized. And here is who I am. I am Lansky, COO of Devconnect, and Devconnect is a project that allows you to run validators and other nodes with one single click privately on your own machine and without any technical knowledge. Plug and play hardware that's pre-installed with our free open source software. And of course, the free open source software that you can. This is how it looks. We have a dApp store where you can install all of the dApp stores, LSDs, Rocket Pool, Hopper, private key for your accounting, Avalanche, an OP node, etc. You have this dApp store, which is a smart contract on Ethereum, and the distribution of the package happens over IPFS. So you never connect to a server that we control. And then we have like nice UI things that we have developed, like these stakers UI, where you can choose an execution client, a consensus client, the keys on the Web3 signer. You can choose which relayers, whether you want OFAC compliant or not, and all of this without touching any sort of command line. So Devconnect is great for non-technical users because you never need to touch command line. It's open source. It has a permissionless SDK where you can create, you've seen all of these apps like Rotkey and stuff. You can create, if you have your own chain, you have anti-chain, then you can create a package and put it on the dApp store permissionlessly with our SDK. It has built-in tooling, like a VPN to connect to your Devconnect from wherever you are. Even if you have this server in your own home, you don't need to deal with IPs or networking. We take care of this with a WireGuard open source VPN as well. It is great for POS staking and runs great on normal hardware. You don't need anything special, a NUC, and we have an amazing community that will help you debug or troubleshoot or anything weird. Now Ethereum, a little bit what happens with Ethereum. We don't know how many dApp nodes are out there. And we don't know how many validators are out there. We have no idea. We have no way to know because we have no telemetry. When you run dApp node, you run it in your own machine and there's no telemetry. You install the software from GitHub and you put it in your machine. But when you use dApp node, the default validator Graffiti is validating from dApp node. And from this, we can extract on-chain data of all the validators that have left the Graffiti without changing it. And then we come to a minimum of 3,376 validators as of yesterday, self-reported as using Devconnect, which is around $228 million of solo stakers using Devconnect. So that's, I mean, with this authority, if this is any authority, I think we provide some value, and this is how we want to provide a little bit more value by moving beyond solo staker. We see the limitations for it, and we want to move beyond it. One last thing, and I got to shield that, because we secret launched our smoothing pool. A smoothing pool for any solo stakers that don't need to have Devconnect. So solo stakers here, you are subject to a lot of variance when it comes to MEV rewards, and when it comes to high fees, and when it comes to block proposals. So you don't know when you're going to propose a block, and if you're lucky, you're going to propose more than 3. If you're unlucky, you're going to propose less than 3. So subscribing to a smoothing pool allows you to earn rewards consistently and smooth out these rewards. Same for periods where the fees are high. Maybe you propose 3 blocks, but they're all at moments where the fees are really low. Finally, the MEV lottery, you don't know, if you propose 3 blocks a year on average, which is, you get to this number by multiplying the number of validators now between the amount of epochs, of slots in a year, and you get 3 of them. So it's very rare that with 3 blocks you'll get a lottery block. They're called lottery because they are rare. So subscribing to MVP smoothing pool can substantially reduce this variance, and for most people that will make them more profitable. So the official launch will be next week, but it is already live since yesterday, and you can already subscribe your validators by going to smooth.dabno.io. And this is the alpha. If you do that, we are currently donating. You see this donate button over there? This is a public goods funding mechanism. You can donate directly to every single solo staker by donating to the pool. Every single solo staker that subscribes to the pool, of course. So when we have critical mass of solo stakers subscribe to the pool, we can literally incentivize solo stakers and bump up their rewards by donating directly to the pool. So not only it's just beneficial and you will get more rewards, but we will do campaigns as a community to get people to donate, maybe a Gitcoin grant, maybe a Giveth grant, to donate directly to all of the solo stakers that are in the smoothing pool. Now enough with the intermission. Now you know where I come from. So now you know the problematic. And the good news is that we have the solution already. The solution already exists. We just need to put the pieces together. So number 1, we need liquidity. If we need to put more validators in places that are not centralized, that are outside of the US and Germany and Europe and the Western countries, what we need is liquidity. We need permissioned and permissionless models to accept new node operators. These new models usually currently require either a bond, like Rocket Pool, you would need a bond of 8 ETH, or a DVT, which is not clear how this is going to be or what bond you're going to need, but liquidity. But you got to convince these people. You got to convince these people, the liquidity providers, the people that have liquidity, like Lido. Lido gets a ton of liquidity. Ether.fi has liquidity. Stakehouse has liquidity. Stakewise v3 will create vaults that will be able to aggregate liquidity. So all of these have the liquidity, but how should they trust a node in Kenya? The other piece of the puzzle is communities. Communities that are groups of people that translate the language, that try to overcome this language barrier that we're talking about. People that have ability to pool economic resources, and communities that already exist and that already are embedded into the ecosystem. We have ETHKipu, ETHKL, we have like a bunch of different communities all over the world that could go to these liquidity providers, these liquidity aggregators, so to speak, and say, hey, we want to run validators for you, and this is where Lido community module is going, and where the vaults of Stakewise v3 is going, and where the operation solo staker from EtherFi is going, etc., etc. And now, finally, but okay, so even then, if I am a community in Kenya, it's going to be hard for me to convince a liquidity provider to put liquidity in my node because it's not going to be reliable. So here's where the pieces start coming together. You need hardware infrastructure that, thanks to the software layer, all the DVT solutions have. You can run it on different hardware that, because of the qualities of DVT, you don't need even to have it 100% uptime. You don't need to have these nodes up all of the time. You can have lower performance because if you're part of a group, by the way, everyone aware of DVT? If you've been listening in this conference, you probably have heard of DVT. Yeah? Is there anybody that doesn't? Don't be afraid of raising your hand. Okay, everybody knows about DVT, perfect. So yeah, thanks to DVT, it becomes like, basically these communities have the power to organize and offer performance that's very similar to a professional operator, and in any case, even better than a solo staker. If you were saying that solo staker was what the protocol was designed for, and the protocol was very permissive and accepted the fault tolerances or like the little ups and downs of a solo staker, when you are a community staker, this variance is even less. So you're even better than a solo staker. So we have the 4 pieces. We have communities that can run hardware infrastructure, that runs software, DVT, and that has the ability to, running all of this stack, to present themselves as trustworthy node operators for liquidity providers. So they are able to attract liquidity and become node operators for these liquidity providers, or for personal entities, or for even for themselves. So this is not fantasy, this is happening. There's the DV Stakers group that reached out to us and said, like, hey, can we put a dApp node in Kenya? And we said, fuck yeah. And we put a dApp node in Kenya, and there's like a bunch of DVT nodes with Operation Solo Staker. We're building a blog with ETH Kipu. Want to hear ETH Kipu? There we go. We're building a node with ETH Kipu, a community node. This one is in Kenya. This one, I don't know where that is, Ebonayo of Africa. But yeah, we have like nodes all over the place that all of a sudden they couldn't participate in the network directly because they didn't have the ETH and they didn't have the reliability. And now, thanks to that 4-layered stack, they can. So, communities are spread out all across the world. They can gain access to revenue from the base layer that is non-speculative revenue if you believe in ETH. It is low investment, but you get high exposure to the upside of collecting this base layer, this base ETH, and it can be very useful for redistribution of wealth as well for the decentralization of the network. It can be very, very beneficial for the network and for breaking through this Nakamoto coefficient of 1. So one of the things that we are considering a dApp node, this is not a satanic pentagram. This is a cluster of 5 nodes. And when you have a cluster of 5 nodes, you don't actually need them to be running full nodes. You don't actually need really beefy machines and everybody to run a really expensive machine. You actually would need only 1 or 2 beefy machines that are able to run a full node, an Ethereum full node, and the other one could be the backup, and the other ones could be like ARM, Raspberry Pis, really low-powered machines that really only have like a key share, and they keep signing these attestations, and they keep signing these proposals, and they connect for beacon and execution. They connect to these 2. So we get a setup that overall the cost is not much higher, not a lot higher than what we had before for solo staking, and it's a lot more resilient. It's a lot more resilient. You get a coordination layer based on the community that can also coordinate and aggregate and be able to attract liquidity because they are semi-professional, they are community, they are a new class of stakers, they're community stakers. And with something like this, it can become a reality real quick. So, who thinks the bull market is coming? So some people think that it's already here. Beautiful, that's perfect. So don't be the virgin DeFi crypto bro. Don't be exit liquidity. Don't, like, TA is not a thing. All right, I love this meme, I made it myself. What you should do is be a Chad staker. Stack LSDs on your machine like they're pancakes. And this is a very, very attractive, non-speculative, or at least not that much speculative option that you have for this new bull market and capture all the fee revenue that will happen. If you want a dApp node, hit me up. And you can install it. It's free open source software. And I can teach you how to do it. You can go to our website. We have tutorials. We have everything, dappnode.com. There's a Twitter for dappnode. You can change Twitter for a letter X, apparently, I heard. And follow this, Paul Lansky, that's me. And join our Discord to have some proof that we are not coming out of the woodwork. We were there, and we in fact have a really strong community. Thank you very much. Thank you very much, Lansky. We have a few minutes for questions, if anybody has one. feel like the president now.
All good? Okay. Well, thanks you again.
Perfect. Thanks to you guys. You missed a really good talk on the other session.
Start now. Okay, so I have the pleasure of introducing Amitej Gajala, founder of Stater Labs and KelpDAO.
Hey everyone, thanks a lot Nixo for the quick intro. Thanks everyone for joining today. I'm here to talk about liquid restaking, a new DeFi paradigm that we're building. I'm not going to talk a lot about protocol that is building this liquid restaking, but I'm generally going to talk a little bit about the evolution of staking, liquid staking, and the next paradigm in line, which is liquid restaking. Just for quick context, everybody, like the entire Ethereum, like in 2015 is when the global alternative layer for value exchange and value network, and in 2020 is when staking was introduced, obviously with a minimum of 32 ETH. Anybody could spin up their validators to run an ETH node, and then in similar time frame, liquid staking was introduced, which kind of democratized staking, kind of like the pioneers include Lido, Rocket Pool, etc. And then in 2023 is when ETH restaking was introduced. Restaking platforms like EigenLayer and a couple of other versions of EigenLayer are really making this restaking ecosystem popular. And the essential concept of it is, for those of you who are not familiar with the restaking and the associated networks, the essence of the idea is to kind of reuse the decentralized trust network of staked ETH in providing security for other dApps or applications or protocols that want to actually use decentralized, build decentralized networks. So let me get into a little bit of details. Just like I'm going to skim through this very quickly. You're all probably familiar with the fact that how liquid staking democratized staking for everybody. Now, like with liquid staking, we don't need 32 ETH to kind of participate in staking. So these guys really kind of brought down the barriers for staking for everybody. And then the additional two advantages of liquid staking was it was very capital efficient because people could participate in DeFi, earn additional rewards, yields, etc. And then obviously this brought liquid staking got liquidity to staked assets. This was very important back in 2020 when there was no withdrawal time period on Ethereum. Yeah. So just like how Ethereum kind of offers a global alternative for building financial applications, restaking kind of takes it a step further because of the additional advantages and the potential applications that it could actually bring in. So essentially, the way so basically the idea of restaking is that there is billions of dollars of staked ETH that can be reused for providing security for other applications, dApps, or any kind of L2s, or potentially multiple other applications like oracles or applications needing programmable slashing, etc. So they are the prime candidates that can use this restaking networks like EigenLayer. And what we are kind of building is a liquidity layer on top. The reason why we are building that is because we believe there are going to be a lot of challenges with regards to with regards to restaking as a paradigm. And some of those challenges are highlighted here. One is this is going to create extremely complicated UI UX for a lot of users, because as a user, when you're actually restaking your Ethereum or any of the liquid staked assets, you're going to be restaking those with obviously two major players in the ecosystem. The first one are essentially the validators who are validating on a restaking platform like EigenLayer. The second ones are all these services, which includes the dApps or applications that are being built on top of these validators on the restaking ecosystem. So now, as a user, you have to actually choose between node operators and the applications that are participating in this restaking ecosystem. That really complicates the user interactions. So that's one significant barrier to that's one major barrier to restaking adoption that will exist in the long run. The other one is obviously when you're participating in restaking across multiple applications, you're going to be rewarded in multiple different tokens. So for example, protocol A rewards users in ETH, protocol B rewards users in stable coins, and protocol C, D, and E in their own native tokens. So there's already 5 different tokens that users have to actually claim, pay gas fees to actually like harvest their rewards. So this is going to make their experience extremely complex. The third one is obviously losing liquidity. When users restake their ETH or LSDs, there is going to be a unbonding period that is going to be imposed by platforms like EigenLayer. So there is an instant loss of liquidity that users will face. So all of these 3 major barriers exist in terms of adoption for restaking, though there is a significant frenzy around EigenLayer airdrops, etc., that attracted a lot of capital. But if you kind of remove the noise around airdrops, so these 3 are going to be the major challenges that users will face in the future when choosing restaking platforms. And how do we solve these? That is where we believe LRTs, liquid restake tokens, can elegantly solve some of these, along with some of the risks and challenges that some of the restaking platforms are going to create in the future for Ethereum. So how do we solve it? Essentially, when users restake their Ethereum or restake their LSDs, we're going to issue a simple receipt token. For Kelp DAO, it is called RSETH. So now that restaked token represents the underlying ownership of the restaked assets and is also eligible to receive restaking rewards like airdrops, etc., of the AVSs that are going to be using these restaking platforms. So that's going to be like extremely capital efficient for the users, because they're not only going to get ETH staking rewards, but they're also going to get ETH restaking rewards along with airdrops, etc. And then on top of that, they will be able to use this token on DeFi platforms like Aave, etc., for collateralizing or for providing liquidity across Curve Balancer, right? So it is going to be like probably liquid staking on steroids. Now, it is also going to create a better user experience, because the LRT platforms are going to abstract the complexity of claiming these multiple airdrops in different types of tokens and give those to users in a single transaction. So that will take away the complex user experience that restaking is going to introduce. And because RSETH is just like any other token like RETH or STETH or ETHX, etc., it is going to have, so protocols are going to build liquidity on AMMs and potentially on centralized exchanges also in the future. That is going to unlock liquidity, so they don't have to face any kind of barriers in terms of withdrawal periods or unbonding periods. So LRTs are going to elegantly solve the problems that are created by restaking, while also enjoying the benefits of these restaking platforms. Just want to pause a little bit because I covered a lot. Any questions so far? It does move next. I also want to cover some of the risks that exist with restaking networks like EigenLayer, that we believe LRTs could potentially be able to solve some of those risks. One of the major risks that is highlighted when it comes to restaking platforms like EigenLayer is slashing related risks, because this introduces additional potential slashing risks on users' staked ETH. The way LRTs could solve this is by selecting a bunch of operators who are well known and would have the network infrastructure necessary to run staking services in a much better way than So that is going to limit the slashing risks for users. The other potential risk that restaking is going to introduce is centralizing the network a lot, where all the users are going to choose like brand named validators for restaking their Ethereum, but with protocols like HelpDAO and other LRTs, they are going to limit the centralization risk because they are going to allocate the restaked capital or restaked Ethereum from users' deposits across multiple operators. And once there is a lot more clarity in terms of the AVS or the restaking services that are being developed, or or the services that are utilizing the restaked assets, like ways and means to sort of onboard operators permissionlessly is also going to be a reality with the required bond amounts. So all of that, all of those checkpoints in place will limit the centralization risks associated with restaking networks, right? And the other one is obviously impacting social consensus, since I'm sure some of you have read Vitalik's paper on how restaking is going to burden social consensus for Ethereum. One of the ways and means to sort of limit this risk is by selecting services or applications that pose limited risk to users' capital, so that need for a hard fork is kind of minimized in the future. So that's how we believe LRTs can potentially solve some of the risks with regards to restaking, and these are some of the mitigating factors we are considering while building our solution in the Kelp DAO. And yeah, so this is our Twitter handle if you want to follow Kelp DAO. Happy to answer any further questions. Thank you, guys.
If nobody has any questions, we're going to take a short break. I think we've got 5 more minutes until the next speaker. They're the most multilingual people I've ever met.
Yeah.
Ready to go? Okay. Okay, for joining us, I'm here to introduce you to Emily Raffo, who is the co-founder, founding partner, and head of sales at Chain Security. Thank you for joining us, Emily.
Thank you. Hello. Ooh. Hello, everybody. No, that's not going to work. Thank you very much for coming. It's the end of the day, and I know that Darren is speaking over there, and still you chose me. I'm incredibly thankful. I'm going to put a timer here. Hello. Oh, amazing. So today I'll be talking to you about slashing insurance. First of all, I have to apologize. The title is sustainability, and I didn't mean environmental sustainability. I meant sustainability of business model. So if you're here to talk about the environment, wouldn't be offended if you leave, because there's no environment in this presentation. So you might want auditing company would be talking about insurance. And like Clément just said before, it's because a lot of people are asking us if we're planning to offer insurance products. So we started looking into, would it make sense? Should we kind of start having this offering also? The answer is no. We're not going to do that because it is indeed, you have to. Insurance is not such an easy thing, as you guys might know. You need to be a risk professional, you need to raise capital, you need to do all these things, and we prefer to keep focusing on what we do best, the smart contract audits. But we still kind of interviewed a lot of people, did some research, and then I kind of found an interest to this insurance sector. So this is why I'm going to be talking about this today. And we also have some staking clients, so this is also interesting for me in that sense. Before starting, I'd like to thank all the people who gave me interviews. You have their Twitter handles there. And if at the Q&A you ask me a question I can't answer, I'm going to refer you to these people. So you can ask me a question, I will ask them. So yeah, they gave me interviews, so it's both on the kind of staking side and on the insurance side. And yeah, it was really invaluable for me to have their inputs. And some of them are in the room today, and I thank them again. All right, so before talking about insurance, I kind of wanted to talk about the different risks that you might want to insure and the different actors, right? So on the left, I've put the slashing risk, on the right, the downtime or offline risk. And so in terms of the slashing risk, I kind of have this kind of vision that as a solo staker, you're going to have less risk of slashing because you are less likely to have this infrastructure for backups to avoid downtime, so you're less likely to have this double signature, right? So this is why on the solo side, I've put the probability of slashing less, but the probability of downtime or being offline higher. For some of them, for example, for Rocket Pool, I've put kind of plus or minus because you can have professional stakers, professional node operators, and also solo. So this is why it's kind of both. Then in terms of the impact, so for solo stakers, obviously the impact is fully assumed by the solo staker. But then if you look, and that's I think kind of interesting, node operators like Lido are kind of these B2B. So when I put node operator, SAS, so it's staking as a service, so kind of this professional stakers, right? And there I've put the impact a lot for Lido. You're going to say, okay, but why it's not them who have the capital, right? So that's kind of strange. But actually, in the facts, it seems that in order to preserve their reputation, which is very important in the Lido ecosystem, right? You have to perform, otherwise you risk getting off-boarded. So in the end, there is kind of a high risk that as a node operator, you're going to have to pay back these slashing penalties to the DAO to kind of maintain your reputation. And this is another side of the impact. It's not only something that is financial, it's also reputational. And if you lose your reputation, you lose your future ability to earn because you risk getting off-boarded or you risk getting limited. However, for the professional node operators, more on the B2B, so the staking as a service, so maybe more in a traditional business model, offering these services to institutions and so on, I've put the impact a little less. This is a personal take, because I find that in a kind of traditional business model, you have maybe a bit more stickiness when you have these business relationships that you create with people. And if you kind of cover the, the penalties, there is less chance, I would say, that, your business partner kind of leaves for a few things. Whereas with Lido, there is a lot of attention on you as a node operator, and you really have to perform because you have all these DAO members who are going to be pushing to get you out if you don't perform. So for Rocket Pool, I've put the impact as high because there is the collateral, but there the reputational risk is less important. And for Diva, you also have a collateral. Now, in terms of the downtime, so it's not a huge financial aspect of it. But again, for Lido, there is this reputation aspect. And also, I've looked at 10 cases of offline penalties and rewards missed and so on. And also, again, it was the node operator who paid it back on a voluntary basis to maintain the reputation with Lido. And for Rocket Pool and Diva, I've put the impact not too high because there's less that reputation aspect. And also these missed rewards and the penalties are socialized. So all of this to say, who would want to be insured in this whole thing? So potentially the liquidity providers for Rocket Pool, for Diva, they wouldn't really want to be insured because they're insured by this collateral, right? So the people who are taking this risk are the node operators. They're the ones who have their collateral at stake. So on this side, potentially, they could be the ones who want to get insured. Now, in terms of Lido and the B2B staking providers, it also depends on the contract, and also sometimes the node operators take on that risk and take on these penalties, even if they're not the ones contractually required to do so. So in this case, they might want to get insured. But also, the liquidity providers might want to get insured because maybe they don't trust the node operator to pay, or maybe they think, okay, this is too much of a risk to bear. And the solo stakers might also want to get insured because they have their stake there. So I compared these three insurance providers. It's obviously not the only three that exists, but it was kind of easy to find their data and to compare them. So yeah, I took Nexus, Chainproof, and Insurace. And so the first thing, obviously, is the fee. So it kind of depends on the proposal. So for example, if you look at the Nexus proposal and the Chainproof proposal for simple DVT for Lido, you can see somewhere that it went between 3 and 3.55%. But for example, Nexus for Figment offers it for 2.5%. What's interesting also is what is excluded. And I think that's kind of interesting, is that, so the missed rewards are quite often excluded, but also if there is a widespread network issue, so more than 10%. So if you're looking to get insurance for a catastrophic event, this type of event might be excluded. Bugs of the client software are also often excluded from insurance. So yeah, I think that's kind of interesting. If you're comparing insurance providers, kind of what is excluded is super important. The max available coverage is also very interesting. So this was the max offered for, again, the simple DVT. If you look at Nexus and Chainproof, and Insurace is the max that is possible based on the capital that they have at the moment. So, in the other kind of DeFi insurances, you've seen that, with the USD peg and all these kind of big events, a lot of insurance providers had to pay very big premiums, and kind of that wasn't great for the sustainability of their business model. So you have kind of these limitations in terms of risk that they want to expose themselves to because they want to be diversified. So for example, Nexus, you can go up to 20% of their capital pool to insure one type of risk. So I think that's like $56 million, 27,000 ETH. It's in the next slide. But so yeah, there are these limitations so that they would be able to pay if the thing actually happens. The deductible is also super interesting because I said if you have this huge catastrophic case, maybe it's not going to be covered. But also if you have this small case, maybe it's not going to be covered because it's lower than the deductible, right? So this is also something that's very important to look at when you're picking an insurance provider. something that's very interesting, I interviewed these people, and they haven't paid any claims yet. So this is a very sustainable business model, actually. So when you look at the rest of DeFi insurance, Nexus is actually the only insurance company in DeFi that has received more premiums than they have paid. All the other insurance providers have paid more than they have received, so it's a very, very rough space, and this is why we decided not to go in there, because people expect very high returns if they invest, in these insurance services. Then the clients expect to pay low premiums, and so it's kind of very, very complicated to manage this trilemma. Also of keeping the funds safe, of course. The KYC, kind of interesting. Insurance doesn't request KYC. And then the other thing that's kind of very different is that chain proof is a regulated insurance. So if they don't pay, you can sue them. So that's one thing. Whereas the other ones work on chain, as we know, kind of as crypto-native insurances. There's also Realm. There's also DSLA. There's also, some insurance from Blockdaemon with Munich Re. So there are other options, but I kind of put these three because it was kind of, 3 is a good number, I guess. Okay, so who does what? Lido has opted for self-insurance. They used to be insured with Unslash, and kind of the conclusion of it is that it was quite expensive. So the problem is that, what I showed you before, this here, so the yearly cost is in the percentage of the max value covered. So it's not the percentage of what you make, it's not the percentage of your profits. So actually, it takes quite a big chunk of your profits to insure your staked ETH. So the Lido kind of estimated that it was 25% of the revenue, what they paid in insurance, and they kind of thought that the risk wasn't really worth it to go with an external insurance provider. So now they have this self-insurance, so they have this fund which covers these cases. And we'll see afterwards a case and see how it was used and why. Rocket Pool and Diva, they have collateral, so the node operators deposit collateral. And then the B2B node operators, so these staking as a service, kind of these professionals, more on the kind of a traditional business model. It seems that often they suggest, when you invest in them, they suggest that you take an insurance. So you can take an insurance with Figment or something with some of these providers, and then the liquidity provider is going to bear the cost of this insurance. But you also see in cases, for example, these cases here on top, stake.us, it's a node slashing event, but it was their fault, and they admitted to it, and then they paid back their clients. So we can see a lot of cases where it's a trust-based business. And when node operators commit a mistake, it seems that they often pay for it. And then the launch node case, so the two cases below are with Lido. And they're quite interesting. So for launch nodes, it was quite recent, it was last month. And it was a mistake by launch nodes, again, double signing and so on, because they had this backup that was triggered. And they paid back. Again, they paid back the DAO because it was their mistake and because they want to keep the relationship with Lido. So there, the Lido insurance fund wasn't even used. It was the node operator who bore the cost of the slashing. But with Rock Logic, it was different. So that happened in April. And it was actually a bug in Prism, in the client software. And there, so it wasn't their fault. I mean, some people argue with this, but it was judged that it wasn't their fault. And there, the Lido fund was used in this case because it was not the fault of the node operator. So I think it's kind of interesting to compare these two where the insurance wasn't used. I mean, a third-party insurance wasn't used. And I think it's interesting to see, okay, what if they had an insurance with Nexus or Insurace? Again, I took these two because it's kind of easy to see all the stats on chain. And so what's interesting is that, first of all, with Insurace, there is a maximum coverage, right? So if you look at huge node operators like launch nodes and WorkLogic, who have hundreds of millions under management, the max coverage wouldn't cover a big part. They would only cover 0.24 ETH per validator. Some people might say it's enough. Some people might not say. It depends on how you see it. But in both cases, with InsureAce, both events would have been covered, but the fee, the claim that would have been paid back would not have been as much as the yearly cost of the insurance. So having a self-insurance could have been an alternative to this. But interesting with Nexus, the WorkLogic case, where it was a bug in the client software, and then the Lido insurance fund paid for it. Actually, this wouldn't have been covered in the terms of Nexus. So I think that's kind of interesting to see. So these are very rough calculations, right? I took ETH at 2K, just to kind of give a rough idea. But I think it's really interesting to see, okay, am I ready to take this risk or no? And is it worth paying for it? So if we look at number of slashings, so it's rated from this morning, you can see that maybe it's, I don't know. So it depends, kind of what is your risk tolerance. I'm very risk tolerant, so I think I'm not sure. But the people I interviewed, they kept mentioning that insurance is really, and they think is for institutional actors, is for people who are regulated, who want to offer to their clients this extra insurance. And maybe it's a little box that should be ticked by the compliance team, or maybe it's like car insurance, where you sell car insurance because it's mandatory. So a few people that I interviewed kind of see the evolution of this insurance sector for slashing to be connected with regulation and with the entrance of institutional investors. And that maybe crypto natives kind of are dealing quite well with these self-insurance solutions. So I'd like to thank again all the people who helped me with this and who gave me their insights. And thank you guys for being here at the last presentation.
Great, so we have some time for a couple of questions if anybody wants to ask questions. Questions? All right, I actually have one. Do you see insurance kind of disappearing as things can get built in protocol? And so if regulators in the future expected some kind of insurance to come with some sort of protocol, do you think that could be built in a way that insurance wasn't necessary?
So I think there you would have to have DAOs recognized by the authorities as a kind of a regulated insurance entity. For now, there are not that many kind of cryptos that are regulated. So yeah, in the future where DAOs are legal entities that are recognized, I could see that, yeah.
Cool, thank you very much. Thanks for coming.
Thank you guys.
We have a 5-minute break, and then we're going to Jorge Arce. Ready? Are we ready? Okay, please join me to the stage Jorge Arce, who is a researcher at Nethermind.
Hello. Okay, hello everyone. Good afternoon. Thank you for joining me for the entire conference. So I'm representing Nethermind Research here. Sorry. And today I'm going to talk about, my name is Jorge Arce, researcher at Nethermind. And today I'm going to talk a mechanism for decentralized maintenance of Lido's operator set with a focus on white labeling detection. So that's a lot of words. I would like to get into the nitty-gritty of what the research is about. To give some context, this research project we're going to today is a collaboration that was born between Lido and Nethermind researchers with the goal of designing a mechanism for decentralized maintenance of Lido's operator set. And to be slightly more specific here, there have been efforts by community staking or permissionless staking to the protocol. You may have seen a talk by Dimitri, one of Lido's contributors, I think earlier today, on the introduction of the community staking module. And this research fits very nicely with this community staking module that currently works only via a bonding mechanism. And we are looking into more sophisticated mechanisms to increase the capital efficiency of this module and bring down the bonding requirements. So stuff like identity, reputation, and even civil resistant or white labeling resistant mechanisms via game theoretical approaches or so are part of the sort of like prongs we're using to approach this research. So this is a multi-phase research project. For phase one, we did, whoops, sorry about that. For phase one, we did a systematization of knowledge for identity and credentials. This was completed late last year. And we looked at over 100 different implementations of identity, decentralized identity and verifiable credential stuff. We selected like the 70 of those that we thought could be relevant to the problem at hand that could be integrated into a Lido permissionless staking module. We delivered something that looks like that, a big database where we indexed all of these papers. We ranked them by relevance, quality score, and gave our recommendations as to what to move forward with. I'll have a QR code later on for you to check all of these sources if you're interested. And then for phase two, which is what's going to concern us for the presentation today, white labeling resistance. This was completed in late August this year. And yeah, as we said before, this is one of the steps towards enabling Lido to onboard new operators in a permissionless manner and in a more capital efficient way. So that was phase one, as we talked about. Phase two, this is like a screenshot of the main part of the deliverable. There's a QR code there if you want to have a look. I'll also have the QR code at the very end of the talk. I'm just going to give a few seconds for people who have their cameras out. Awesome. Okay. So I've been saying white labeling this, white labeling that. Maybe I should motivate the problem as to why we care about white labeling. Let us define, very informally, white labeling as what happens when a node operator delegates their nodes to another third party to run them for them, without the protocol, in this case Lido, having any knowledge of that. And there's a few problems with this. This can lead to disproportionate control over the protocol stake by a single entity without us being aware of that or being able to prevent it or intervene. It can also weaken resistance to correlated slashing, and it can introduce single points of failure if there's a single party that is holding a bunch of stake behind the scenes. And finally, we note that it is easier to deal with this with the standard whitelist module where the majority of Lido stake is at the moment. But as we transition towards a permissionless mechanism for onboarding node operators or validators, this can become harder and harder to deal with. We can see that for Lido DAO, the goal or the attribute that operators run their own nodes, that is that there is no white labeling, is high in the priority list. Right now it looks good for Lido's current validator set. As we go permissionless, we have to be careful. Okay. And so, after some discussions between Lido contributors and Lido and Nethermind researchers, we began to think about doing research on the design of a decentralized dispute resolution mechanism for Lido that would penalize misbehaving operators. So it's hard to do this white labeling resistance in a fully decentralized fashion. Maybe a dispute resolution mechanism can be introduced such that we look at the operator set or the validator set. We identify any offenses that we would like to punish, and we do so. But in order to do this in a decentralized fashion, what building blocks are required to construct this mechanism? Well, so let me walk you through the kind of things that we looked at. We analyzed so-called arbitered protocols, and this is like an umbrella term that we're using for any kind of protocol that can be used to look at evidence that happened either off-chain or on-chain and come to a resolution as to the meaning of that evidence. So here we have prediction markets, decentralized oracles, or decentralized justice protocols. So we're looking at these, seeing which ones are good, assessing the feasibility of using them for the question we have. Then we look at a very interesting part of the research, which is mechanism design. So if we are armed with such a protocol that can provide decentralized dispute resolution, what kind of mechanism, what kind of economic incentives, what kind of bonding requirements you would have to introduce for all the parties for all rational parties participating of this game to behave as intended. And these parties are node operators, accusers, and jurors. I will define them in a few slides. And then finally, as part of the research, we also looked at evidence types against white labeling. That is, how can you, okay, you have a resolution mechanism for the evidence, but what is the evidence? How does white labeling look like on the Ethereum validator set? So that's just a bird's eye view of what the research was about. Here are the 5 tasks that we set upon to resolve in detail, and you can find more details in the deliverable. So I'm going to give you a brief overview of some of the interesting findings of these tasks, as much as time allows us in this today. And so let me start with task 2, in the interest of time, SOK on arbiter protocols. This time we looked at like 35 papers and implementations of arbiter protocols in the space. We started looking at prediction markets, which you can define as, well, essentially any mechanism or protocol where people can bet on binary outcomes of future events. So you may have seen a few of these prediction markets going around, and intuitively, given that the prices of the binary options in a prediction market allow you to interpret what is the mean belief of the traders participating of the market, and they're also backing this up with capital, you wonder, is it possible to use this as a way for people to kind of like, in a decentralized manner, resolve what is the meaning of a given piece of evidence? Unfortunately, we have found that most prediction markets require some kind of trusted party to come in at the very end of the process and give resolution to the prediction market. So like say, okay, this was the truth, this is the option that wins, this is the option that loses, despite it having been in the minority, right? So removing this trusted authority from the prediction market, it's kind of hard, and actually lets us to naturally takes us to study other kinds of arbiter protocols that we will explain next. There's also decentralized oracles, like any mechanism for bringing off-chain data on-chain, and there's a few we're familiar with, Chainlink, there's Nest, there's Yuma, so on and so forth. Normally they use different types of economic incentives to remain decentralized, and the main problem here, although this is a step in the right direction already, but there's many kinds of oracles that are not the most suited to deal with subjective interpretations of data. So they're very good at reporting a numerical value or whether an event, some kind of event, but maybe not so much the significance of that event. And this is where we would like some kind of oracle that was like more subjective to look at these kinds of things. And so we come upon these third category of arbiter protocols, decentralized justice. So just a formal definition, protocols that use blockchain technology to decentralize dispute resolution by crowdsourcing the adjudication of disputes to a worldwide pool of willing juror arbitrators. So yeah, the most intuitive way to think about this is a subjective oracle, where what is relayed to the chain is a resolution as to what's the significance of a given piece of evidence. Here, similar to the case of decentralized oracles, we leverage financial incentives for people to rule truthfully. For example, we use something that is known as Schelling point mechanisms, where you have people, you restrict people from communicating with each other, and you ask them a question, And so the natural equilibrium point that arises is, sorry, and I'm missing a very important part. And you only reward the people that vote in the majority, and you punish the people that vote in the minority. Assuming that people cannot communicate, the truth arises as sort of a natural equilibrium, although it can certainly be gamed if by some kinds of attacks, which is something to be aware of when studying these protocols. So yeah, after looking at these things, decentralized justice protocols came out on top for our study, and we analyzed a few of them. We found some very interesting ideas on how to address the different kinds of attacks that a decentralized protocol normally encounters by the Kleros protocol. It seemed to be the most mature amongst the one we studied. And we also analyzed some critiques of decentralized justice by law experts, but I'll spare you the details for now. Okay, so let's say we are armed with a correct dispute resolution mechanism, which could be either something like Kleros, or in the case that there are challenges towards the integration with such a tool, then some kind of dedicated fork of equivalent functionality. Then what we need to do next is the interesting part, where you construct a mechanism that involves these three parties that I was referring to before. You have the Lido operators, and you ask these people to post a bond, which, by the way, as we will see later or validate later, this bond is much, much smaller than the bond that you were required to post for general slashing protection. This is good because it keeps the mechanism capital efficient. There's also, and if they misbehave, if they do white labeling, you take that bond away. There's the accusers. So these are parties that will be incentivized via this game to submit a case with the appropriate evidence to the mechanism. They post a bond. They also must post a bond in order to prevent any kind of griefing mechanisms where they just submit cases without any substantiated evidence, and they just are trying to game the mechanism. So to prevent this kind of spamming, they also must submit a bond, and they stand to gain a reward if they are found to be in the right. And then there's the jurors, who will be appointed by the mechanism to arbitrate the dispute. They should be knowledgeable to understand the significance of the evidence, and they split a reward, the court fees that are taken from the losing side. Here's a brief diagram of how the whole thing can be put together. You have the validator set up here, especially for the permissionless case. You have evidence providers. These are people who are not directly appointed by anyone. This is completely permissionless. They look at the validator set. They put together a case as to whether someone is doing white labeling or not, and they submit an evidence to the dispute resolution mechanism, which would integrate with Lido contracts and leverage some juror set in order to come to a resolution. Okay, so the question as to what's the right way to economically tweak this mechanism for the economic incentives to match the game theory for a rational actor is very interesting. To give a very intuitive and quick overview of what's going on, you would compute the expected profit of someone delegating their nodes to a third party that is doing white labeling and getting those middleman fees. So you would take that expected profit. You would also consider sort of the probability of being caught as a function of time, and this is a probability distribution that becomes large, or we model it as something that becomes larger and larger as time goes by, because the more evidence you're sending out, the more you're doing this, the more likely you're of being caught. And given that probability distribution, we computed, okay, what is the expected gain for this person before they get caught? And so once you have that, and involves some nice stochastic analysis of the whole mechanism, once you have that, what is the punishment that you need to apply in order to make these people be in expectation, that is on average, in the red if they try to apply white labeling, to lose money on average if they try to do that. And so this depends on a bunch of variables. This depends on the price of ether. This depends on the mean time for detection. This depends on the probability of being detected. This depends on the probability of the court coming to a just resolution, because we cannot expect a perfect court. And put all of these factors together, we generated a simulation tool to be able to compute that crucial answer, like what would be the necessary punishment to apply in order to have these people in expectation be losing money, so that as rational actors they would not attempt white labeling. You can find this in the deliverable as well. the link, the QR link that I shared earlier, and I will share at the end as well. And we come to this graph, and to explain the significance of this is the minimum accuser's reward. That is the minimum reward that must be paid for a white labeling case as a function of the number of validators involved. We have a linear offset here, simply because to make a small case worth the accuser's while, you need to, well, provide some, at least a minimum amount of payment. And then you see that this scales actually, well, linearly, but the slope is pretty small, which is good. Because that means, like, for example, for 100 validators, if someone is trying to post 100 validators, for the mechanism to gain this white labeling resistance property, look at the y-axis. We have something like 5 ETH or so. So that means that with 5 Ether, or like approximately 0.05 additional ETH per validator, assuming the market conditions of a couple of months ago when the research was posted, we could adequately collateralize against the threat of white labeling. And this is, like, once again, a very small percentage of what you would need to defend yourself against slashing risks, which is much more than that, right? At least 1 ETH per validator. This is good, because the goal of achieving adequate capital efficiency, this leads some credence to the fact that this mechanism could work for that. And our deliverable also provides a bunch of other goodies, which I encourage you to check out. Economic analysis on bundling requirements and financial incentives. So kind of like the math behind those graphs and those tools that you saw. A simulation tool to update the above, like these economic analysis versus market and tech parameters. I showed a screenshot. Guidelines for a testnet phase and experiments for initialization. We want to validate these things with some kind of experimental phase that shows that our formulas are indeed whole water. A description of a fail-safe mechanism, what you would do if, like, the decentralized core just stops working from overnight. And strategies for how to achieve juror curation. That is how to check that jurors know what they should know. Okay. And then let's talk about task 4, which I have been talking about the game theory behind making this whole thing work, but you may be interested in knowing, okay, what kind of evidence am I looking at? What kind of identifying mechanisms am I looking at to see whether someone is doing white labeling or not on Ethereum? Well, we reviewed the literature here and the known ecosystem insights on how you can gain sort of like additional information about a validator and who is running a validator behind the scenes. And this has actually been an interesting problem in the Ethereum ecosystem for a long time. To provide a couple of examples, and I'll come back to what has been known for a while, like this relates to some concerns about validator anonymity that have been known since like 2020 in the Ethereum ecosystems when like the transition to proof of stake was first proposed. But coming back to the task at hand, some ways in which you could do that, in which you could identify white labeling would be, one would be using machine learning classifiers or heuristic approaches that are trained on features of the validators related to the validator's performance. So by analyzing the sort of like metrics of validators, you could come up with unsupervised machine learning approaches to kind of like attempt to cluster those validators into their operator sets. And you can ask, like, how effective is that? Like, how much data we have to make this work? And I would direct you to some research, very interesting research by Rated. This article called Solo Stakers, the Backbone of Ethereum, shows how you would do exactly that and how they identified some clusters of whales that were, it was highly consistent that they belonged to the same person behind the scenes. And they used this to identify 6.5% of validator indices that belong with very high probability to solo stakers, but we can adapt these techniques also for the purpose of clustering directly. So that was one thing that we discussed. Another one would be, and this is related to the whole validator, to the discussions on validator privacy that have been going around in Ethereum research for a while, networking layer analysis to correlate validators with the same beacon node. So you could have a crawler on the Ethereum networking layer, and this crawler looks at how attestations are propagated on the Ethereum network to tell whether attestations belonging to different validator keys are likely to be originated from the same Ethereum node, that is from the same consensus node, which would be used as strong evidence that these validators are being connected to the same node, hence being ran by the same person. With white labeling, this works really, really well, especially if someone gets sloppy and just like delegates it to a major, delegates their validator to a major node operator, because they are likely to just mix validators with validators of their own or validators of other parties. Now, and the research goes, or like the deliverable we wrote goes into some more detail on how to make this work, what are some future research directions to follow. I would also point out that this is a starting point. So long as we have the right economic incentives in the mechanism we talked about before, the game theory would lead us to believe that the right people are going to come up and start doing this for profit, right? And this is our intention with having a mechanism that allows people to, once again, make a profit by identifying the white labeling cases. Just to start wrapping it up, some future research directions beyond this phase 2, and going back to the things that we alluded to at the beginning of the talk. Civil resistance, it would be nice for us to have an economic analysis of how does a civil attack look like for our dispute resolution mechanism, and what kind of economic restrictions we need to impose to add civil resistance to the validator set. State-of-the-art approaches to achieve civil resistance in our operator set. We would like some more time to, or go more deeply into the literature and come up with some ideas for civil resistance that work here. And protecting the juror set for civil attacks is also important. Reputation systems, how can you connect these things with reputation so that you're incentivizing the correct behavior of jurors, not just with capital, but also with reputation. Reputation for the operators themselves, and how all these things, what's the big picture of these things put together. So that would be it. Thank you very much for your time and attention today. We are Nethermind Research. If I managed to convince you to have a look at our deliverable, then here's the QR code again. Thank you very much, guys.
So if anybody has any questions, they can raise their hands. No? Okay. Well, thank you very much for coming and speaking. This is actually the last talk of the conference, so thank you very much for coming to the conference.